Okay, I'm here. Okay, so I got the list of all the stuff I need up here. Let's go over the diodes. This is a circuit I used. You can have the resistor before or after this, and you can put a switch anywhere in this, and it just got a switch, which I'll put in later. And that current hat thing, I've got Velcro and some magnets, and I'll mount it to my earphones. I think maybe a hat, but I just soldered the leads to the diodes and just soldered it together quick. There's a bunch of extra wire, and I'm going to clean it up. I just want to test it, and it worked after I tested it, so I've been using it. But let's make a trip over to Amazon, and let's and my parts were more ordered to come quick than they were for price. So let's check PS3 camera. I've been misspelling this. Yeah, I've been misspelling this. Cameras got an E in it. Okay, I'll go to Amazon. PS3. You could probably go to GameStop and buy a used one for $5. Wow. Have they gone up in price? Let's just see. I guess they're going up. Well, I think mine was $10. Okay. Maybe. How much is that? Well, maybe you'll pay, maybe it's $25. Control X. I think that's a bit high, but because at one time, well, maybe there's a shortage of, maybe at one time the price is just super low because there's a surplus of them. And it's COVID and people doing Microsoft Flight Sim. Maybe people, because people are doing this for Microsoft Flight Sim too. PS3 camera. Let's see. I don't see any. Buy. I bet if you go to eBay, find one a little bit better. PS3 camera, eBay. My eBay account doesn't work. See, yeah, they're listed for $15 over here. That's the game. I want the camera. Where's that puppeteer include the camera? I don't know. Let's see. Two-pack. You get two of them for $25 a piece. Well, the curved lens is the one that they say to modify and take apart and take out the IR filter. I didn't do that. I got in the mail one without a curved lens, so the IR filter's in the middle, and I wasn't convinced that I'd rather not block that much IR. I mean, it doesn't block that much visible. So I decided instead to go with okay, well, I've shown the camera, so all the items in bold are expensive items. So we go into the camera. That's PS3 kind of, that's what people say you can get them in GameStop, so I'm going to guess that's $10 to $40. $10 to $40. Some of them I think we saw them for 34. Lots of them for 34. 10 to 35 dollars. Just depending on how long you're willing to wait for it. Go to GameStop too. You can find them there. Let's go back to here. Go to Amazon. Gel packs. Red. We don't need. I didn't use red. I hadn't tested it, but my thoughts are red's close to ultraviolet. Green, blue, yellow. Well, let's just say gel packs. Call them gel packs. Gel pack. Transparent. Colored. Plastic. They're just colored plastic sheets. Okay, that's what you need. Find the cheapest one you can find with the least number of colors. What you need is, I use green, blue. Oh, I wish I had a purple. That's Roy G. Biv. That's violet. That's probably could have used that. I probably would have used, if I had that one, I would have used green, blue, and violet. But the set I got was, it had 4 of them. I just, about 2 weeks ago, yeah, I ordered this one. I ordered this gel pack. So let's say $8. Let's see. I mean, if you do extensive search, you might find it cheaper. Let's see what I got it for. Orders. I really don't want to show all y'all my orders. Let's see. Well, orders. I gotta return something. Amazon's making it real hard for me to return it. This is what I got it for. I got it for $7.50. So gel pack. There's build mount. I don't have it listed. Is it listed somewhere else? Yeah, gel pack. What do they call it? Call it gel pack. I don't know. A gel pack. Oh, and I'm gonna try to correct some things. I said points smaller than 5 pixels and larger than about 5 or 10. No, smaller than 1/2 a pixel, larger than 3 to 5. It's smaller. It's bigger than 1/2 a pixel. And I'm showing 1.5. I don't ever see it go over 2, maybe, and smaller than 3. So I'll show you those filters in the software. But basically, opentracker. We'll bold that. It's not something you got to buy, but it's kind of, you got to get this right. COI test. B. So opentracker, it reads your camera. You can set which camera you use. I'm just saying the PS3 camera because it's cheap and it's 60 frames per second. My Logitech camera is 30, and I want to use my Logitech camera anyway to stream with. So, but gosh, that PS3 camera comes in focus. That Logitech camera, it can't focus. Can't focus close up. And you know, you would think a PC camera you'd need to focus close up because you're close to a PC. PS3 you wouldn't need to be close, but this one's got good close-up focus. I think I don't remember me being out of focus. And the Logitech shit, but I think that maybe that's the driver. I don't know. But I'll go over the software, but we'll go over the build now. Okay, so we went over the. Let's go in order. Okay, infrared diode. This is what I got. I bought extras. These are all over there. I picked this one. These are all over Amazon. I got. Now let's open up the picture. Now $9 for 3 of them. So we'll say 9 to 18. I bought 2 sets of them in case I screwed up. You might screw up too. So I'm going to put 9. Let's just say 9 to 20. If you're confident with your soldering and you can get it in one try and not break everything, definitely if you solder a lot, then I just buy 3. You know how often you screw stuff up. I bought 2 sets of them, so I got spares. I think I bought 2 packs of them, so I spent $18. But the price is 9, and that's price is more. I think they're coming from China and had long lead times or something. So you might be able to, you might find it for 5. I don't know. It's this thing. Let's do a quick search on that. I bet that's lower. And there's our 6 ohm resistors, 1/4 watt. Let's put that in. You'll definitely, if you don't use my circuit, you need to check the power and you're not overloading the resistor. I checked it, but 5 ohm one will be. Will 5 ohms stay at rated current? Let's see. The voltage across it's a 1/2 volt. I'll tell you. And the voltage squared divided by the resistance. 50 milliwatts. Did that calculation right. 6.8 enter times 6. Just don't get hung up on little details. I got an audience here. Yeah, I'm getting 0.5 enter times 6.8 divide 36 milliwatts. Need to be below 250. Okay, so I guess it's not a factor. Yeah, it's I wrote the power is V squared over R here, but it's the voltage across resistor. The basic way, you start out at 5 volts. You can have the resistor before or after, it doesn't really matter. Those circuits are 1.5 voltage drop. I don't know if it says it, but you can look up the spec sheet on it. Or 1.5 volt drop. Let's look up. It's SFH, and the good thing about these are wide angle. They got a 40-degree half angle. And I'll talk about why I thought mine wasn't good at first and bent it up and stuff. Quit buying. $14 for 10 of them. So you can get 10 for $14. You get 3 for $5. 5. That might be a good. You can pay the extra 40 cents. Yeah, so you can get. So we'll say $6. Let's just screw one up. You can spend as much as 2 of them for $8. So yeah, so we'll drop that to $6. To $5. 5. Somebody might find them for 5 somewhere. $5 to $20. I bet you I got mine for. I bet I got 2 for $10. I mean, I bet I got 6 for $10. I don't think you should spend more than that. $10. Okay, and then if you just search on specs for it, you can see the specs for it. Okay, long USB cable. Yeah, you can find something to cut up. You just got to cut it up. There's a red and a black wire. That's your power is red, and your ground is black, and then make sure you put tape, electrical tape around the white and the green wire so it doesn't cross conduct something. People say you shouldn't plug it into your computer. I can't see why, because USB is rated for the amount of amperage we're drawing, and if we got those other wires, if we had those other wires insulated so that we can't get cross flow across the white and green. There's 4 wires in there. You're just using red and black. I don't see how it can affect your computer. But to be safe, I have one of those power strips with a USB on it, so I just got plugged into that. But I think that's just internet people saying, you know, the spec for USB is as you go from USB 2 to USB 3 to USB to higher standards. Those others carry signals that tell it when it can go higher amperages, but we're not using a higher amperage. This is a 75 ohm amperage, and I'll go how we calculate it. 5 minus 1.5, well, 3 times 1.5 is 4.5. So the 5 volts gets a 1.5 drop, and we could have put the resistor after it. As a matter of fact, I think I'll do it. That's how I made my circuit. No, this is how I built the circuit. But the calculations came out just the same. It's going to be too hard to fix this. So 4.5, that leaves a half a volt. So to figure out our current, it's a half a volt divided by the resistance. So a half a volt divided by 5 ohms, 0.5 divided by 5 equals 0.1 amps, and a milliamp is 1,000 ohms. So that's 100 milliamps. Amps, we'll have the decimal, and then you shift it over 3 places to make it a milliamp. I say things wrong. I know what I think in my head, like when I said 2 places. I don't want to just go on talking and assume everybody knew what I meant, but it's a milli. It moves it over 3 places, division by 1,000. I made some mistakes on the pixel size. When I was talking about the pattern, I made all sorts of mistakes. It'd be hard to follow what I was saying at times, but these are the electrical equations. That's most I'm going to talk about the circuit, because V squared divided by R. Because you can look up DIYs on that, and that's basic electronics, and and there's also calculators. Just make sure if you use a calculator, it says whether the resistance are in series or parallel, because it makes a difference. Anyway, let's go to the parts, and then I'll go over the build with some pictures. Okay, so what I did was I just I took a diode and soldered on. No, we're going to go over the build parts real quick. Velcro. I hadn't used the Velcro yet, but I bought some. I don't know how much it was. I bought it in bulk, so I don't know if I should count that. But I have Velcro now. So we know the camera, we know the gel pack. Yeah, that's the only part. So we're up to 5. Oh, we didn't see how much resistors were. They were back. Alright, we'll have to get over to your orders again. I really don't want to go through. Bought 10 of these. These will burn up if you put more than 1/4 of a watt. So remember, I was saying ours is, with mine at 6.8, it's using, I don't know, 68%. It's a rated circuit at 100 milliamps, and I'm using 74, so I'm using about 3/4 of rating. I got 10 for $5. So these were $5. You probably not going to get them much cheaper off Amazon if you buy less, but we just put down $5. put it over here. And I'm not going to look up. If you want your light brighter, you can get the 5 ohm ones. I don't know how much longer it lasts if you derate it or not. I'm going to guess it'd be 30% brighter if you use about 1/3 more power. But I wouldn't go lower than 5 ohms because you're going to go over the rated current. Unless you talk to an electrical engineer about it, because I don't know that much more about diodes. I am a mechanical engineer, but I did very well in my electrical engineering classes, and I have a master's in mechanical engineering, and I have an advanced software, and I'm a software engineer. I took a year's worth of college studies to get an equivalent engineering degree in software engineering that was paid for by Lockheed Martin. So it must be a good program to be a working software. And lots of working software engineers are just engineers who don't have any courses in software. They just start doing it. So I have a year of studies in C++, real-time circuits, web stuff, Ada, what do we call this? Hardware level stuff, software engineering. I had 10 courses. I don't know. Years worth of studies. Heat shrink tubing. I don't know if I should count that or not. I think you can get that for $5 if you don't have it. I don't know. You don't need to use heat. You can use electrical tape. Since we use the electrical tape to build this, I'm going to list that. And you'll need some wire. I don't know how much wire costs. I'm not going to look it up, but it's little wire. Oh, I have my parts. So, yeah, I'll come back and show all the parts later. When we go over these little miscellaneous parts, you know. The heat shrink tubing is not absolutely required. You may have it laying around your house. If you don't buy some. I bought it at an automotive parts store, so I paid way too much for it. And I bought a soldering iron, and then I found and that soldering iron sucked, and I found my old one. And I bought a digital gauge, digital multimeter. That'll be very helpful. If you have one, test your circuit before you build it. Just twist. Be a little bit careful. It's all in series, so if you have enough knowledge to know what you're testing, I'll say test it. Or if you can set it up to where you're sure you won't short something out or do it wrong, test it. Yeah, I guess you could. Well, the way we're going to go over the parts first. I keep getting off. Okay, we went over the camera. I hear you can get those at GameStop for $5 or shop around. I think you can get that for $10. You'll read things on it. You'll see lots of stuff about taking the old camera with a curved lens on the front, which mine doesn't have, and taking it apart, and then either taking an X-Acto knife and cutting straight down in just the right way, but they say cut this way, not that way, and I can't tell in the video what she means. I think she means do downward strokes, not cutting across, but you know, if you're wrong, you're going to shatter your lens, and then you're out $10 to $35. And they aren't as cheap as I thought. I thought they were like $5, but I think at one time they were $5. I think in all the articles they were saying they're $5 to $10. And probably when this was invented about this IR solution, there's an IR tracker, a thing you can buy called IR tracker, and maybe something called Track IR. You can buy it for $160. It comes with a camera and basically the same head mount, and I think a hat mount too, which has got sensors over here and over here, but it doesn't work as well, I hear. Or it doesn't work any better, and it uses 4 diodes. So you can, anyway, people figured out how to build all this stuff, and then they got some open source software. First is freetrack and opentracker. So there's also some called freetrack. Maybe that's, but this is the one I'm using. So I think that's all the parts you got to buy. So let me look. I've got a container of all the parts I think that I could show on YouTube. So, oh, and I have some pictures too. Yeah, we'll start going over some of the pictures of the build. And I'll just, okay, probably pictures. Let's go over here. Let's open this up before we get too far over here. Picture, which ones? Phone. Okay, I think those are all right. Yeah. One was my BDO pictures, but that's all right. Okay, so the first thing I did when I built this was I breadboarded it, which you probably wouldn't do since I've told you what parts to use. If you use that LED and if you use a 5-volt USB, you can just use those parts. But I breadboarded it. This thing provides, it's got batteries in it, so it'll provide 4.5 volts here, which wouldn't have, it was just whatever the only power drive, these LEDs are 1.5 volts, so whatever they were lower than that, and whatever the battery was higher, that's all, it wasn't much driving it, but it did show up in a dark room. And then I did later take this positive, see this top bar is your positive, and that's 4.5, that's 3, that's 1.5 volts. And then all the parallel lines are connected together. So it went across this. Another detail on this that I put down, and for this diode, for this exact, it's different for every diode. You guys look at the spec sheet. This exact diode, the long lead is negative. Okay. And I'll show you what I mean by that. Now, bear with me. This is going to take a while. I want to make a detailed approach to how you can build this to give you the foundation for how you can do it. SFH, this is the diode right here. This is in German, but later, or some other language, but later they have, yes, it's that. Reverse, that's if you hook it in reverse. If you hook it, where's it say it's 1.5 volt? Maybe it says that in the name. Reverse, forward current. That's what the current it's rated at. You got to keep it below 100 milliamps, or you're working overrated, which I can't guarantee. And then in that power equation, whatever current you got through it, multiply it by 1.5 volts, and that's milliwatts. So that would be 0.2. That's 0.2 watts. So you want to stay below that. And I have the power. Watts are power. I didn't bring. Okay. Where's it say the drop? Here it is. Forward voltage. That's the one. That's when you run the diode the right way, which is the symbol for a diode. This is a triangle here, not a greater than sign, but that means the current goes from positive to negative. When you look at this picture here, they have a drawing of it, and they say in one of these drawings which one's the cathode. And most digital multimeters have a diode checker, but I didn't trust it. I don't remember. It says cathode on that one. That lines up. The long lead is cathode. The short lead is positive. So the long leads goes to negative, since y'all goes to negative, and short lead goes to positive. Let's be, I'm going to assume positive. Okay, if you want to do it, I recommend you just keep your resistance between 5 and 6.8 volts. I hadn't tested it at 5 volts. It may last longer at 6.8, it may not. It may be 2/3 as bright at that, it may not. I just know it works at that. And it's meeting the specs. Oh, I want to get my bag of parts. Yeah. Okay. For this part, I'm going to turn the camera on. Well, right now we're going over pictures. And we'll go back to bag of parts. So this is it. See, I tested it's going through the diode, then it's going through the resistor. And at one time I thought I wanted less current, so I put these two in parallel, so this dropped it. This made an equivalent 10 ohm resistors, two resistors in parallel. I put the equation for equivalent if you want to design your own circuit, but these two in parallel, because this goes off this lead into here and they go in parallel. And then I had some other circuits just to test it, what's the parallel part, blah blah blah, but we'll just follow this. It goes across that in parallel, then it goes here, and then when I press this button, it closes this circuit and it goes to ground. If I press, let's see if I can remember what it does. If I press this button, it bypasses the ones in parallel and goes right into ground. So this is the circuit that I built. It bypassed. It doesn't have those in parallel. That's me testing it. So where was my thing of pictures at? Okay, so that's about the most pictures I got for building it. I mean, I think I had a rough picture of me soldering stuff, but then I got a better one than that. How does this thing go back a picture? Yeah, so this is after I'd already built it. I'm just showing you. I used a pair of vice grips, solder, and oh gosh, I got that soldering iron when I'm going to say my age, so 35 years ago. More than 35 years ago. I'm off by 10, I think. Yeah. So that's what I used. You don't need more colored tapes. I only had black wires, so I put red on the positives so I could tell when I was done. But the first thing I did was I took I soldered the stuff to the USB cable, just some leads, because it's a much finer wire on that USB. I just soldered some wires on it and marked which ones are red and black. And then I soldered the resistor onto that, put that away. And then I took each, see there's the resistor right there. Let's see, that resistor goes to, okay, I've already built it, so yeah, you can't really see that. But then that goes to the power to the USB. You can't really, you can't really see the wire, the USB part, but okay, we'll go more pictures back. Okay, you need to draw this diagram, which comes from, I'll open up the opentrack, but I'll show that later. I've briefly, okay, it's this one right here. We'll open up the default model file. That's mine, because mine came out a little bit off in dimensions, and I'll talk about why. So, I mean, it wasn't that far off, but then I bent something up to make it different. Here's a model. So once you get the opentrack software, this is opentrack. If you go on one of the options, it says model, and get as close as you can to these dimensions. But mine's not Atom, so I don't think it's critical, and it doesn't. You know, if I had this thing, I don't have my camera up, and if I put my camera up, well, I've gone over. Yeah, maybe if I move my cam, I don't know. All I'm saying is, this thing is not on the center line of my nose. It's on the side of my head. And I have it pointed way out. So, in nowhere did I told it the distance from my eyes to my neck. But nowhere did I tell it the radius of my head or how far in front of it is. And it seems to work. So, I don't think these dimensions are that as critical. But I did lay it out and do that. Try to get it the best I could. You know, I started off, I drew. I don't know if you can see it very well. I drew this diagram of it, laid it out. Probably don't go into that. This is my X point. I went down 70, converted 70 millimeters to inches. Yeah, I have it laid out over here: 30, 40, 70, 80. I measured, I did trig into the angles on all that, and then I converted all the millimeters to inches. That's 1.18, 1.5, 2.7. The best I can measure to is about a tenth, you know. 1 inch I can measure to 1.2, a little bit less, you know, like 1.18 would be a little less than 1.2. I use an engineering scale, but you can use whatever scale you want to. So yeah, you can see this kind of thing kind of laid out over here. I named the coat hanger parts. It's a coat hanger. I changed design later. I don't know if I wrote it down, but anyway, I had a rough idea. Basically, my idea was I'm going to bend a piece of coat hanger like this, and I'm going to bend a piece of coat hanger like this, and I'm going to bend another piece of coat hanger that goes like that, all. I changed it. I got rid of that outside piece. It just went from here to here, to here, to here, to here, to here. Now that's a little bit harder, but that gives it some good rigidity. And then after that, I did that. I changed design, added a third piece to cover this angle right here. I think I added a piece right here, and I added a piece that went like that, and then I added a piece that went like this. And I think I added a piece that went like this, a piece that went like this, and then a piece like that went like that. Whatever works, you know. I had 3 pieces that I taped together, but initially I started out with 2. So you can kind of see it. This white piece is a piece that goes all the way around here, and then these things are that, and just lay out a pattern of it. Keep bending until you meet the pattern. But in the end, I changed it, so because, and I'll tell you why. And I changed it because of a mistake I made when I was testing it, and it doesn't seem to matter. It works great. So it's not to those exact. This is what. Let's go to freetrack. See, I tell you why I say it doesn't matter is this is the dimensions they say to have, and I was probably close to them, and I had all 3 leads. As you'll see here in these pictures, all these leads were parallel, and then I put straws in it to get it to the right distance. Like the basic angles were there, and I cut the straws until it was the right distance. And then let's go back to our pictures. What picture are we on? Yeah. Okay. Yeah. See, see how the end of this, and this match that. We're on the part of building the frame for it, which the opentrack will tell you. So get it close. That's all that matters. It's not that critical. And I'll show you why. Okay, I'll tell you why. When I was building the camera, as you'll see, I think in my last video, well, I'll do it again. Those gels that I showed you. Well, I have the parts here, so we're gonna switch to the camera here. I just have to remember to turn it on and off at the right time. Okay. this is my gel pack, and as you see, let me take it out so you can see it a little bit better. It came in these big 6-inch sheets. I didn't use the red. I cut out the yellow. Well, when I was testing it, all I did was I cut that. First I just put it up here and just put it on the camera. Well, you have to see what my setup looks like to know what I'm saying. So I get the mirror out. Okay. So the camera higher is my Logitech camera that's streaming me right now. I don't need that for freetrack. I could turn it off. It's just for streaming. This is the PlayStation 2 camera. But you see that little circular thing in the middle? See if we can. Okay, how can I get this to work? There. See that gray? That's a piece of cardboard. Actually it's a toilet paper cut up, empty toilet paper cut up, and then in one of the streams I deleted because it didn't stream. Just cut it around the circumference and bend it over, and just cut this gel out right here, tape it to it, and then work out a way to tape it on there. I'm not going to go into all the details of it, but basically what I did is I just follow my finger around the circle. I cut radially around the outside of it, and then bent that over, and maybe a real long piece I taped down and just got it in place. And once I had it in place, I started cutting it about a 1/4 inch out with those radial cuts, bending it over, taping it to the toilet paper. And I had in mind the toilet paper is probably going to sit closer to the top due to gravity. I mean, it's just scotch taped on there, and the camera's just taped onto my monitor. I've ordered a mount for that camera, but for now this will work. And so just find a way to tape this on there, and you can use whatever colors you want. Other people say to take apart a floppy disk and use that for what you're trying to do is filter out the visible light, and so there's less. That's what makes it dark. But I'm going to go into the PlayStation Eye software for a second so I can make a point here. I'll show my desktop, and then I'll open this up, and I'm going to pin this to the taskbar. I don't think this. Okay. There's only two. You pick the camera you want to use. I could use a Logitech camera, though. Oh, these are the cameras. It could even come from that and not use a Logitech camera, which that Logitech software is shit. But anyway, I wonder if that's why my. Wonder what I don't really. What that's going to put to. Well, it doesn't really matter. That's not what I'm. That's not the point of options. I don't really care about the audio. I don't really care about capturing stuff with this. I do care about this set frame rate. Oh, I should have 67 here. That's what my software is doing, is 60, so it's dropping a lot of frames. Okay. Okay, I set the software. It'll go. This camera will go up to 75. Oh no, that's for capture. That doesn't matter. This is what it's sending to the thing. So I guess it's a smaller pixels. Doesn't have a big high, but it's got a high frame rate. Now I wonder if I could drop that down. What would happen if I use 320? Oh, let's don't worry about that for now. You could even send over 75, but I decided to go 67, leave some margin. It seems to be working, so it's fine. You can go 75, but you can set the frame rate in there, but that's not the key thing I want to show, because I was talking about the gel filters. Okay, I got the exposure all the way up. So if I turn the exposure down, it gets darker. If I turn the grain, I don't know if I really want to mess with this. Okay, I can remember where I am. I'm just going to put my finger here. It gets more grainy, it gets darker. So I've got a lot of gain on it. Shoot, I don't know why I put that on. It should block out a lot of blue. Okay, this is more filtering, so that's not what I had at last. Let's do that. I'm not hesitate to play with this a lot, because just put it there and leave it there. You do want to turn off auto exposure. Okay. So the purpose that, see, the thing about this, let's put this on. The thing about this head clip is it sends out an infrared signal. And infrared is lower. I think it's longer wavelength than visible light. Ultraviolet is shorter, and as you go way out there, it starts getting into high energy radiation. But we're not. You make sure this is okay. This is about where this should be. I don't have my headphones on now. Nobody's watching this, but okay. So don't have my face cam. Okay, so I'll turn on face tracker, which is on. Close that, and then we'll get face tracker tracking right now. Okay. It doesn't like both these being on at the same time. Oh, I was showing you stuff earlier. I just went through, see, that's what I don't like about. I just did a whole intro that you don't know what I'm talking about. Okay, what did I say on the camera? Okay, I got gain settings. These things, I'm going to put my finger on it so I don't lose its position. If this gets real high, it gets grainy. So I think the default is 0. Don't put any of these on auto. Or don't put exposure on auto. Exposure, if it's low, it lets in nothing. So I had exposure all the way up. Let me turn on my head camera. There. You see those lights right there? This is a daylight. I got a window either over here. I think the window's over here. Window's probably a little left. There's a window right big here in the back of my room. So in the morning, it doesn't even see that. Because I got the exposure up. I built those gel filters. I just took a around 12. I'll put up the small camera. See? Okay. Then let me look over here and see what we're. Okay. So yeah, so there's a small camera. See, but you know, this is just that CLI is a little utility to set those down to red, green, and blue. You know, like I said, it seems to work. I just picked red, green, and blue so that light looks kind of white. And I know I don't have a red filter in there, but I got a lot of blue filtering and stuff. And so that seemed to work. I noticed when I opened it up, the blue was way over here. So see if it tracks worse, but I don't think it will. So we'll try to track again. And now I'll try again. I think I need to close this, or at least need to close this properties one. Let's apply that. So you'll need to adjust your exposure so it's somewhat black. So this is distinct. But if you got big lights and small lights, there's a way to filter. Instead of this thing looking for the brightest things, it'll look for the size of them, and that's the filter I use, and I'll show that. Okay, so we'll close that and see if it'll track now. It still may say Yeah, it's just when I got a dialogue open, it doesn't want to work. Nope, it wants me to close this. Okay, we'll try again, and then hopefully I won't have to restart it. Okay, yeah, now it works. Okay, it's not tracking it now. It was tracking it. Wow, I changed just a couple of things. Oh, there it is. Yeah, but it's not tracking it as well. Huh. That's weird. Let's go back to what the settings were. Shoot, I changed the settings in there. It's working great, and I just happened to switch that blue over. See, I think the blue was over here. That's weird. How much difference does that make in the brightness of the lights? Isn't that weird? Infrared would be below red, but whatever. If it works, it works. Oh, I didn't have exposure all the way. I want exposure all the way up, and I want a bunch of gain. Okay. Let's apply that. Now it should work. Isn't that weird? It was that finicky about it. Okay, we'll try it again. I'll tell you what your goal is on this tracking. Still not as bright. It's not seeing those. It's not seeing those great. Well, we're going to have to play through a little bit. Wonder if I can open up that eye camera now. What could I change here? Okay. What was it? 60s. This is what I used. Oh, okay. That's what. Somehow this got. Oh, I know what's wrong. I'm setting stuff up over here. I'm on the profile. Okay. I panicked myself. We'll go back to what I had, and I'll show you it'll work. I know what's wrong here. Video capture filter. We'll leave it there. That's what we start. Well, let's just see. I bet this works with blue down here. Should make more sense to me. We'll just see if that works. Okay. Here's the problem. This is the default INI it comes with, which I opened up to show y'all what I'm using. How to build the model. I opened the default one up to show the recommended model size, which is that they copied the track IR. But the thing is, in that, after you build it, there's a calibration. You just move your head all around it, figure. So I think of the model's a little bit different. As long as it's close, it doesn't matter. But I'm in the default. This is the INI I should be using. So I bet now when we see, yeah, see now? So see, these points aren't getting too much bigger than 2 pixels. If I get real close, it might go up to 3. If I get far back, it might go, or if the brightness went down. This one's real big. This one's, yeah, sometimes it thinks, you know, we could even take that down more. So occasionally it sees that, but not often. I bet if I took that down even more, it'd help. Okay, so the filter I'm using on this, we'll see where it was. Is it here? No. Was it here? Yeah. Okay. Let's take this min size down one more. No, let's take that up. No. It's max size. Let's take that down to 3.5. 5, and then don't be so stupid. 3.5, and then we'll take, it's always going to be bigger than 0.9. Okay. So it's always going to be bigger than 1. I think it went up to 3 if I moved way up here. And I move way, yeah, it's always, it doesn't get smaller than 1 point. If the light wasn't bright, it might get a little bit smaller than that. So what did I put in for that? I could put in 3. 3.5, that's a good margin. I'd say 1.3 is a pretty good margin. If I let it get smaller, I could go to well, oh yeah, I needed, yeah, see when you look up and down, that's why it's doing so well. So we'll take that to 0.5. That's why I'm getting such good angular response with it. See, it's not straight ahead you're worried about. It's when you tilt your head. There's less light coming out the diode. So as long as it's meeting those conditions, it's good. So I can get good angular off with this diode. Because this, and that thing there comes through occasionally, but not enough to really matter. I mean, I could adjust my camera down too, where it just wasn't in it. I could, you know, then it puts me at the top of my thing. So I could adjust the camera up too. But I'm just saying, if you do have a small light, you can put something over there. It's reading that thing so rarely. It's seeing it, but it's not. It's 0.56 pixels. Maybe we could move the camera. No, I've already calibrated it. I'm not going to mess with it. It's working. But you could move the camera around and move that out of the way. Or I could change the exposure and get that in the camera. You know, you change the exposure and these things get brighter and dimmer. I could put in more green filter, but I think green's just what's left over out of the visible light the way I got it filtered. But well, I guess my point was on this, turn off automatic threshold and don't use threshold filter. Well, we could try that and see what it does. But see, these are going out. It's not getting those points sometimes because its threshold means the brightness of it. And I'm kind of upset I even touched it because it was working. But yeah, so it's just looking at where those dots are as I move my head. You can see me moving my head here. This is the software that will send things to your game. So this dialog, you set that what your camera is. I don't know what this does. I've played with it, hadn't figured it out, hadn't touched this. Oh, I hadn't touched this. Maybe I should. I did it with the camera. Which, okay, I got exposed. See, as you go down, it lets less through. As you go in, it lets a lot more through. I mean, I could just adjust it. As long as this thing's gone. That's a light. That's a bright light behind me. You can't see it, but it's in my picture. It's above that guitar. You see behind me over my, as you look at the computer screen, to your left there's a guitar, and that's that bright light. That's a lamp light. You might see a shaft going up. It's coming up above the light. So yeah. So anyway, I guess the key was don't use threshold filtering. Use this min size, max size to get stuff out. Just figure out where it is and figure out what gives you good margin. I think I had that at 0.2. Let's go down to 0.2 on this one here. Oh, why is it not? Oh, I've got this window open. I don't know what to do about the gain. I'm not going to touch that because I didn't touch it. But you might be able to adjust it here too. Instead of, I adjusted in the camera, but it might be easier to adjust the exposure over here. I don't know. But I did a lot of it here. But the thing is when it's blue, that means it recognizes it. There's a blue circle around it. I think that's just the occasionally it may be seeing something there, it may not, I'm not sure. But it's not confusing it, whatever's happening. And I think before I set this, when I set this real low, it makes it more likely that this may. It's still catching that sometimes, so it doesn't matter, but it doesn't seem to get confused about it. One thing that it could is when I do this, you know, those lights are staying pretty much in line. Well, it would see that as translation, but I would think it'd be smart enough to know this is a rotation and this is a translation. But I would go into curves and I'd move my head and the translation curve be moving, so the software's not written right. Because it's, if I configure, I could, you know, student should be doing quaternion math, not trig, but whatever's doing trig or quaternion math. It's just a relationship of those points. It's just are they staying in line with a slight rotation to a head moving? That's a translation. If they're moving apart like that, that's a rotation. I mean, I know how to do transformation matrices, and both through quaternions and matrices math, and I don't know why it's not working, but when I jump ahead, but this thing, when it sees those dots move, it can send yaw signals out, pitch signals, and roll signals. This is a roll. This is a yaw. Yaw is the word no. Pitch is the word yes. And I don't know what a roll is. Is that a head nod? What's it's moving your head back and forth to the side. But it is kind of hard to tell. You know, a true translation would be moving from your hips. I mean, what's a roll? You know, that's like, you know, if you did roll and translation, that might make sense. You know, your eyes will do. If I roll my head to the side and look at something, your brain, although the picture coming in is at a diagonal, your brain keeps it, and your inner ear keeps it looking like that. But the way this would work is if you rolled, it would roll the picture. So that may not be helpful. But anyway, I've got yaw and pitch working. I don't really need a roll. I thought it might be nice. Just a slight roll, 15 degrees. But now that I think about it, it's probably not helpful. Because with the brain, well, the aircraft rolls, yeah, maybe so. I don't know. And then these are translations. This is why I would be moving your head up and down, which you can't do much. All you can do is bend your back up and down a little bit. Unless you stand up. And it is kind of nice to be able to look over the aircraft and straight, but you can't do it. And then Z is zoom in and zoom out. But I've got that bound to my joystick, and I think it's going to make this very confusing if I'm doing zoom. I may add these later. I'll play with them a little bit, but if they're not adding a lot of value and they're messing up the yaw and pitch, which is the most important thing is the yaw and pitch to me. The rest of it I can either put on my Logitech Hotis. This is pretty cool. I just bought this, but it's expensive, but it wasn't the most. There's units that cost twice as much, so we weren't adding that much more value. But there's units for 1/4 the price that'll get the job done too. All you really need to play this game is if you're willing to do your key functions. You know, we'll say we'll limit you to 10 functions on the keyboard. You can try it out and see if you like it, which I did for about a week. And I liked it, so I ordered these parts. And I played lots of flight sims earlier, and I got kind of limited by the whole view thing. It's just I was spinning. First, the joysticks didn't have enough buttons to even map views to it, and then second, you know, the mapping, you have to get back to center and you get lost on where you are and you crash. But this is what I started out with. It was this, just to see if I'm in the camera. I wish there's no this twitch. If I look at the camera, it's always gonna be centered in the picture and put in the center. So I had rudder over here and stick on my left hand, which why did I do it that way? Because I have to press these buttons. I need my right fingers to press those buttons, and I don't want to take my finger off the stick. But the problem with that is, and DCS will allow you to have modifier buttons, so you can pick out 1 or 2 buttons that let's say, okay, a PlayStation controller has. We'll count the D-pad as buttons. The D-pad's 4. Each axis is 2, so that's 6. 4 buttons is 10. There's a trigger and 2. Well, if you have an Xbox controller, these triggers will work. They didn't work for my PlayStation, but would you say there's 10? So the back ones are 10, 11, 12, and then the 3 on the front is 15 buttons. So you can have 15 functions, or you can select one of those as a modifier, maybe your left stick pressed down, and now you've taken away a button. But when you put commands modified on that, you now have 28 functions you can map. With 14 you can get to real quick. The ones where you have a modifier, maybe they're the less useful ones, you don't use more on. Or you could also map stuff. So I had 3 things mapped. I had the left button, the right button, and the PlayStation button. So that brought it from 15 to 12, but 12 times 3. No, I had 3 buttons, so 12 times 4. I had 48 functions. A max of 48 functions on that. But I feel, first, I'm just used to working sticks on my right. And I know, it sounds stupid, but my right thumb is more coordinated than my left. But in the stick, I just think on my right side, so I'm not quite as coordinated, and I'm not as coordinated with a thumbstick either as I am a joystick. And I have about 120 flying hours in real planes, and I have thousands of sim hours and more to less realistic sims. Okay, so I kind of went off on that, but because then I was talking about my joysticks. But we'll just get back on subject. This isn't my setup. This is how to build this. So okay, so we went over that one dialogue here. You can touch this. DCS uses track IRR, so, but you can leave this on both. I don't think it matters either way. I hadn't touched that DLL one. I think you would use this if your game's not recognizing the protocols. That's all I guess. And if I stop, let's stop tracking for a second. Okay. Opentracker could be used with we're using a point tracker, which came with it. I never installed it. But I guess you could use it with an Oculus Rift, joystick, all sorts of stuff. So the default is point tracker, so I don't know how it works in these other things. So I assume this is just, I think it's the format it's going to send stuff out in. Or maybe this one's the format. Yeah, this is probably the format thing. I'm using freetrack enhanced. And that's probably sent out IR track and freetrack enhanced. But you could send it out in a Microsoft format for flight sim or a mouse or any, I don't know. But so I really hadn't touched these options. This is the one I said I hadn't touched a lot. I assume that's the format because track IR is what DCS says, and the defaults is both, and it seemed to work fine both. I don't know why. At one time I was troubleshooting this and changed it, but I'm not going to switch it. This is smoothing. My understanding of it is it's going to work a little bit slower, which I hadn't seen it slow down. So, but the curves of your head will be less jerky as you move this to the right. But if you get it too far to the right, it can't keep up with how fast you move your head. And dead zone, there's a manual and open. You can read their explanation of it. I think dead zone is, I don't know, it's kind of like a dead stone on the joystick. That's my guess. And you can do that for rotation and position filtering. You know, maybe I needed to put, no, I don't know how to get that translate. I couldn't get positions to work. So maybe I needed to adjust this. I don't know. I just couldn't get it to work. I couldn't get it to work reliability. It recognized me yawing my head, which I really only cared about the X and the yaw. But it couldn't differentiate between me yawing and me doing this. You know, maybe if it called a yaw translation, but either way it couldn't. So we'll stop that tracker. Usually doesn't like to track with that window open. Options. Okay, I've put in shortcuts on. When you press center, if let's say I was looking off, it got confused, and it doesn't get confused a lot now that I've got everything up. But if it did, you just press that button and center. And now one reason you might want center, which it seems to have a pretty good. When I first set it up, it wouldn't. I'd only go off a little bit, and that's as far as it could recognize things. And it's when you see in that tracker those things, those blue circles around it, means it's tracking it. When the blue circle goes away and it's just an X, it guesses there's something there, but it's not meeting its filter criteria. So I've kind of jumped ahead. We were talking about something different. Let's make sure we've covered everything in our notes that I want to talk about. We'll come back to how to build it. Oh, there is one thing I want to say. I kept saying it doesn't matter about the shape of it, but I didn't have enough information to give you the background of why. Notice in my design I ended up with, first I just soldered on the leads to the 3 diodes, soldered a resistor onto the USB and a lead onto that, and said, well, before I trim all these wires and get it on here, I ought to test it and see if it works. So I tested it and saw if it worked. And then I said, well, before I do all that stuff, I ought to try it in the game and see if it works. And it worked, but it didn't work that great. And for my filter, I hadn't built that toilet paper thing, the toilet paper ring. You can use any ring. You just need to get a ring that's bigger than the PlayStation camera and tape 3 gels on it. And then work with those colors in your camera setting if you have a PS3 and get it somewhere and then just test it. See if it works. Oops, I lost an alligator clip. I know which one it probably is. You know, I've got Velcro. At the time I put this on, it didn't have Velcro. I got a little in an automotive shop, but not much. I didn't have much Velcro. And I didn't have... And I got some magnets now, so I could... adhesive on some magnets to my headphones and then put this on there. But I want to get something that can, although I don't think it matters, you may need to recalibrate it. It takes all of 2 minutes to calibrate. I just turn my head for a few minutes. As you go left and right a few times and up and down, do it for about 2 minutes. And it says it got 90 tries, got 30 good calibrations. I don't know how many times we really need to do it or not. I didn't really, but it's not very hard to recalibrate. Actually, I can calibrate it faster than the damn software starts up. It takes the software. Sometimes it just opens up, and sometimes tracking just starts, and sometimes it takes a minute and 40 seconds to open, and it takes the tracking a good while. So I do have, there's something with my, but Windows will do strange things on my computer, so it could be something with my registry or something. But let's get back on subject. Notice in the picture all these lights were parallel. Well, but I went up. My design was to have this light be right here, and it's pointed up. When I first did it, when I was just testing the prototype out, and that's why these wires are all over the place. I hadn't cut them down to length, and I could cut them down to length and put heat shrink tubing over it, make it all pretty, but I hadn't done that yet. And we'll talk about how I built it later, but I just want to get, all I was doing is taking that gel paper, which I have. I put it back in my, oh, here's my parts. I better keep this over here so I can get to it. I'm handy. I was literally, I got my camera on now. I literally just taken the sheets I was using, bent it over like that, and laid it over my camera. That's all I did. And then I tried to tape it to my monitor. And that was my filter while I was prototyping it. And it's working, but this bottom one, I think once I was having hardly any yaw, and then another time the bottom lead was, no matter how I wore this, if I wore it high up or down, I just didn't, I only had about 10 degrees up and 10 degrees down, or 15 degrees up, and I'm supposed to have 40 degrees off center. So maybe if I got, in a monitor to monitor, to the edge of a monitor is about 24 degrees. I don't know. Do we have the free track? Oh, it's not tracking right now, but we can watch. So it wasn't tracking well, and I was having a hard time setting on my curves because I hadn't gone into. I went out in the mapping real briefly on my last video, but let's see. That starts tracking up. It takes a second to start, but I think there may be something with the PlayStation camera, and it's messing it up. Could be I might play with that exposure. It could be one of them setting exposure and the other one is, and it may be getting nothing, and then decides it's just going to turn its exposure off. I'm not sure what's happening. But anyway, we'll wait for it to start tracking. It will eventually. Well, it'll have to be on here. But so yeah, so I had this tape, the gel paper taped over my camera, and and it was losing the bottom point. And if I would adjust this up, it got better. And so I bent this up, thinking, well, that's just weird. This thing is supposed to have foot. So when I'm up, it sees, and so I assumed that diode here was out of spec, and it was seeing up better than it should be. Like this diode should see 40 degrees up and 40 degrees down, but this diode seemed to be able to see up but not down. And so I bent another coat hanger at this angle you see right here, put it in, and put electrical tape around it. Used it, and it worked a little bit better, but not that much better. And then I looked at it and said, oh, but the reason it's doing is I got a big piece of tape at the bottom of where I taped these gels on, because remember I hadn't built that little cover. I hadn't built an actual filter. I just taped up a bunch of stuff over the top of my camera. My camera's flopping all over the place because it's taped to my monitor. So So yeah, I pulled that piece of tape off and it was tracking it fine. It was disappearing behind the tape was a problem. Is when my head went up. And as I lowered my hat up and down, it changed it, you know, different. I was wearing my hat like that, but it had to get up higher to pass the tape. So anyway, so I think I made a bunch of conclusions off that, and I bent this thing up. So I'll probably bend it back even and measure what the dimensions are and put it in. I'm not so sure. It doesn't matter how you build it as long as you put in the dimensions, or it doesn't even matter. But I know once I fix that and put a real filter up there and then adjusted, looked at this picture and saw what the size of the points it's reading, and then I showed you how we adjusted the point size over here. You know, and notice those points are big now, but if I get big angles going on this, those points will get smaller, see? So the longer the lower I have my threshold, the more to the side I can go. See, I'm 70 degrees off center right there, and we're losing that. It's spec to 40 degrees. But that kind of makes sense because we looked at the spec sheet on this earlier. We'll go to this. The spec sheet on that. Just do spec sheet on. Maybe I ought to put some of these links in here later. No, this isn't a YouTube video. There is no way to paste it. Well, there may be a way. Maybe I'll edit it and put some links in here. DCS. Make IR headset. This is my spec sheet. Just do technical specs on that part right there, and something will come up. But okay. So if you're looking straight at it, it's at 100%. If you're off 10 degrees, it goes down to, I don't know, 90%. And they spec'd it at 40. So at 40, it's supposedly lost, I don't know if this is half its brightness. At 70, it could be a logarithmic scale. 60 at 70 degrees, it's at 1/4 brightness. So you have to be 90 degrees off to lose all its brightness. You know, some of that could just be regular light, but I don't know. But anyway, by having that real small, it lets you see those circles are getting smaller as we, not in the head movement I can do, you can't see it, but if I take the cap off, you know, they will eventually disappear because there's not enough brightness for it to tell. And look how small they get. So you can test it here. And if I was to raise that minimum size up, what size is that? The points get to be, well, yeah. I don't know. It doesn't seem to be going below 0.5. It may just drop off, but anyway, so maybe who knows? But that's the values I use, and anything bigger than 3.5, it never, you know, if I look straight at it, it never gets higher than 3.5. So that's the filter. So that filters most of that out right there. And I think it's seeing that, but it's very rarely thinking that's a point, because it has to draw a blue circle around it. So yeah, I don't see it saying bad a lot, and the bad could be this one that's picking up. That's bad, so whatever. So okay, so I went to that. I'll talk about I talked about this one. Smoothing I hadn't touched. I'll play with it. It's, you know, if I have a problem, but it seems to be working. And actually, I read something. I may have moved it a little bit, but not much. I could check the defaults, but and I read the documentation. It wasn't real clear on it, but you know. And then I can center it. So I've got, this is my center button. So if I put my head up here, it thinks that's a center now, but I'm looking up. So that's what center does. You know, and it's going out. So let's say I turn my head this way. It thinks this is center, so now it's working. But as long as I look at the center, It thinks that's center, so I guess you can do that. And I have mine set so it won't look more than 60 degrees down, and it won't look more than 90 degrees up. So at 90 degrees up, he gets really thin. He turns into an invisible line at 90 degrees. And then the back side, that's, I've gone 180 degrees when we go to the back side. So, and I don't know. Okay, so that's 90 degrees right there, yeah. Yeah, I've got 90 right on my monitor's edge, which works pretty good for me when I'm clearing patterns, because, you know, that's looking off my wing right there. That's looking off the other wing right here. Wing, wing. And then on the up dimensions, this is looking up as somebody going over my head, which in a turning fight, you're usually looking up. You might be looking a little bit up and down, but you know, you usually don't look over like that. You look back like that. I don't think, anyway, I'm not going to go into that, but okay. So anyway, that's why this is bent up. I went to a long explanation of why this is bent up. Is because I had a piece of tape covering up half my lens, and it was covering up that thing. So I don't think it needs to be. Is this thing? I thought this was out of spec, and I was going to have to turn it. And I was thinking about soldering on another LED, and then getting it at more of an angle like it should be, like I think like that. Right now it's pointed up, but actually this may help. It may. You know, when you think about it, I got a camera where my finger is. Well, this one's kind of pointed up to it, but that one's pointed down to it. So, in some ways, it makes more sense to have one of them. If you're trying to optimize it perfectly, which doesn't matter, you know, each one should point at the camera wherever you have it. So they wouldn't be parallel. But, you know, these things are hard to get in there. I put them in a straw and wrap this, and it's hard to get the angle perfect. So, okay, I've kind of talked about the software, but let's just finish up the mappings. Where this is flat, this area here, right here, I'll center it again. Just look straight at the screen and make sure this is on. Okay, so I'll center it. And then, unfortunately, when you see it go up in twice, one of them's actually moving down the bottom curve because I got that set it asymmetrically mapped below. See if I do that, it goes up the other one. But I don't want to redraw that curve twice, so now it's just gonna, the second time when I go over here, it's just going down on it. So yeah, so when I can move my head about this much, let's see, you can get this bigger or smaller. On the helicopter, I don't mind it moving around. Well, actually, until I get my rudder action better, I probably want to be able to keep my head at the center sometimes and then look to the side sometimes. And the distinction. You can set that big or small. But the more room with this, the steeper this is going to be. So a slight movement moves a lot, you know. And this isn't too hard to control right now. But on my initial prototypes of this, I only had about 15 degrees to play with, or 20. And so by the time I get the steep ramp up here and get a big dead zone, then this is a lot bigger slope. And then it wasn't tracking that well, so it's jumping off, so I wasn't sure what. So the shallower you have this slope, the slighter, the more precision you'll have picking a spot, you know. So that's kind of my yaw, but I'm pretty happy this yaw. I can look at 6 o'clock back, and it's just move your head a bunch and you're at 6 o'clock. You know, if I wanted to distinguish between in that back quarter, which I probably wouldn't ever need to, where would I care if it's 180 or if it's 165? I don't think I'd ever care. 100, you know, you're never going to be able to pick that 160 point, but you're not going to care because your monitor's wide enough you can see those points. You know, so I'm pretty happy with that one. Pretty happy with this one. You know, the only thing as I get better with it, I may lower my dead zone. You know, the thing is I do catch myself, or I may raise it. I do catch myself sometimes just in the heat of the moment. But I think this just not getting used to it is I get it out of the dead zone. I don't think it happens as much in pitch in yaw it happens. I get it out of the dead zone and I'm flying the helicopter and then, why is this thing not going straight? And I'm like, oh, I need to straighten out my head. But I'll get used to that. You know, you just got to think, instead of mapping two keys and a center button, which you always get lost when coming back to center, or taking the time to map keys to come back. Usually when I played Flight Sim, I had two buttons mapped. Rotate up and rotate down. 4 buttons. And sometimes I might not have enough, but rotate up and rotate down and then rotate and yaw. And I might not have return on yaw. I might just have rotate. Well, I'd have to have left and right. But I usually come back with a center button. So it requires 4 more buttons to be mapped somewhere. And my sticks back then, they were pretty precious. I think I had the old Thrustmaster that worked off a, I think it's an 80B. I think it was it on a PC or a Mac. Was it serial or was it 80B? I don't know. I can't remember if it's a PC. I think it's a PC. See, see, I had a Mac a long time ago, and I played on the. Well, I played the original Sublogic Flight Sim. The original one was a wireframe 3D. It was just something about the size of 6 football fields. I don't know, something the size of a small park or a big park. And I think on the back of the square there was a base. On your corner there were some runways. The other corner there wasn't anything. There's maybe a balloon up somewhere. And then there was an exit. There may have been an enemy runway on the other side, and there may have been an enemy target on the other side. And I think the only ground was just those wireframe squares, as in, see this grid here? We put some more lines in. This is a grid, and then we just turned it in 3 perspective. You'd see a grid, you know, a square right there. You'd see it like that, and that was your horizon. And it was a biplane. I think there was another biplane you could shoot down, and that one wouldn't do a loop. It got its gimbal axis all screwed up. It could do a roll, but it couldn't do a loop. And Sublogic made that, and they made it for the Apple II. I don't think they made it for any other computer. Or somebody made it, and he sold it. He either started a company called Sublogic, or he sold it to Sublogic. And then Sublogic made for the Apple II. And they made the original Microsoft Sim that had a Learjet and a number of jets, a number of charts. Had the New York, Chicago, maybe LA, and somewhere else, somewhere out west. Yeah, I know it had Chicago. I know it had New York, and it had 2 other airports, 2-port area, you know, VOR maps and everything. And then there was scenery. It was no longer a square grid. It was you know, old triangle graphics, but enough to get by, you know. Maybe a tree here or there, maybe not. I don't know. And then Microsoft bought them, and they made it. This is on the Apple II. But I remember that box having, it was a big box, and it had, I think it had a few charts on it. And it flew better, and I think it had a few planes. And then, I mean, I could be confusing when Microsoft first bought, but then Microsoft bought that, just like how Excel was invented on the Mac. When the Mac came out, they wrote a spreadsheet, and they wrote a word processor, and then they later, I don't think they were called, and I think they're even called Excel, but I'm not sure. I think it's called Excel and Word. And then when they got their Windows working, you know, in the early state of Windows, it wasn't a dot-based thing. It was just putting up characters, but it wasn't actually drawn to the screen. early Windows 3, 1.0 or 2, and then later it actually could draw to the screen. And then they brought Excel over, and that's where it came. But it started on the Mac because they had that software when the Mac came out, and Microsoft wrote it just like they wrote software for. Bill Gates didn't start. He wrote software for. I think he wrote software for IBM too. For their people are going to correct me on this, but their BASIC or their whatever. And he just copied some source code and changed it a little bit and got it working. So anyway, yeah, we're going in these curves. Why was I talking? Why did I go into such depth about? I don't know. I was talking about views and the flight sims I've done. So I did those two, which are really all three of those. And even I never even thought the first Microsoft flight sim felt like a real plane that much. But there was a game on the Mac called Hellcats or the Pacific, and it seemed to be modeled. And by then I had some prop time, about 60 hours in the T-37. Recent time. This time's 30 years ago now. I had 60 hours in the T-37. About 35 hours in the T-38, just for contact check. That's about 30, we'll say. And I had about 30 simulator. I think more of it's T-38 than 37 because I don't think we did simulators a lot. We just did a few emergency, but it could be more 37. I can't remember. Or it could be even. But it's a total of 120 hours plus my prop time, which is less than 15. So 135 hours, but the time in the 38 was very recent to me when I was doing these, and the 37, so I had a feel for what seemed right and wrong. So, but the Hellcats or the Pacific, it was pretty good, and it only needed a few. It needed a gun, it needed some trim. The only trim I worried about was needed a rudder command, and I had a real cheap joystick I was using for. But it was fun I used to practice BFM and stuff like that with it in turnings. And I had the book, Shaw's book on fighter combat maneuvers that I read and all the stuff. And I was really into it. And just flew that. Had my friends over and we'd fly it. And, and I tried Falcon. It was terrible. And I think the reason it's terrible is I didn't have a joystick to work with it. But it seemed a little bit too arcadish to me. Now maybe that's, coming from the T-38 and expecting, throttle to really affect a vertical velocity. And, a real plane kind of works like a helicopter with your stick affecting speed, but it's really, there's a lag in going up and down. A huge lag. In the end, when it goes steady state, it's your throttle that affects your descent rate, and your stick forward aft does affect your airspeed. Yeah, that's your airspeed. That's controlling your airspeed, just like a helicopter. But there's a number of cycles where we get there, and you have to correct it there. And that's if the plane is stable in phugoid moments and all that. But so they say to descend, lead with throttle, and then correct with stick, and then to accelerate, lead with throttle, and then accelerate up and down. To go up and down, vertical velocity. Where you think throttle will get you forward, it will initially make you go faster, but the faster speed will make you pitch up, and the pitch up will make you slowly slow down. Now the problem is your reaction when that happens is put your nose down, and you'll get out of phase with it, and then you'll pull your throttle back and go back, and so you'll be doing all this stuff. But if you kind of know where it's going with it. But so anyway, I got off into the airplane talking. But the point is that this Headtracker it replaces 5 keybinds much more accurately. And the problem with keybinds is, move 45 degrees left, move 45 degrees left. Well, what if my target's right in between the two? Then I'm kind of going back and forth, and then I get lost in it, and then I got to go up one. So this just gives you those commands to do that. Now it doesn't do as well and as like if I go like that. I got to test that more, but it may like you to do this, which you'd have to do with keyboard commands, but I'm thinking of it now as a way to do commands to see the instrument panel, to look up over my head, and to get, this is just valuable when you're in the pattern to look over here or there, and to get used to flying with your head moving around. And you know, the problem is I can just go over here and go back into instruments, and once I get used to it, I can do that. If you're doing keyboard commands to do that, you just can't do it fast enough, and it takes you too long to get the instruments that you don't want to take your head out of the cockpit. And my hope is you can do that, and then you can start to get a good. So yeah, so that's, I talked enough. Let's go back to building it. So I covered the parts. I covered as much electrical as I can. I mean, either you're good at electrical and you're confident with it, or you build exact. I mean, practice soldering with some old wire if you're not. If you're buying this for the first time, watch a YouTube video how to solder, and just make this exactly like this is listed. You have to put, if you're going to use heat shrink tubing, sometimes you have to put it on before you solder. You, like if I was going to solder this piece to this piece, I'd have to put the tubing somewhere because I got a piece on either end if it wouldn't slip over the resistor. Let's talk about the build. I had pictures on the build, so you just kind of wrap this up a little bit. I have pictures on the build. Okay, so it started out, you know, my initial plan was to make some sort of strange thing around here and make a better mounting surface. Because coat hangers, especially starting out, were harder to bend at the angles than I wanted. Especially this one, I just could not get that thing going. But later I learned, I just found those best with, I made the best bends with my hands, and I don't have the pliers in here, but just the most simplest pliers with the kind of point. And needle nose, if you have needle nose pliers, those bends will be easy. I couldn't find my needle nose pliers. So 2 pairs of needle nose pliers, you can make any bends you want to make. But I was using vice grips and just normal pliers with about an angle like that on the jaws. Each jaw is about like that. There's a jaw shaped like that, and then there's a jaw shaped like that. They kind of, but it's this outside that lets you, you know, like needle nose are like this. So needle nose, you can get a big bend in all the way. But the fatter your jaws are, the least. And I have just normal pliers have a jaw about like that. So I just take the jaw on it, bend it over. But you know, draw that little pattern that I showed you. Convert the. I've got it written down what most of the things are converted inches are over here. You're not seeing. That one may not have it, but, and I think I've got the angles. I calculated all that stuff, but oh, you know, I had the sheet of paper somewhere around here. But yeah, so we'll go another picture over. I just took a bunch of pictures of it. So yeah, that's just to kind of show it. I don't know. This is me taking some measurements. I did bend this one way up here. Remember I told you why I did it? It did seem to matter. I mean, I just measured it, saw where it was off from the original pattern, put it in. It seemed to work fine, so I don't think it's that. I don't even know if it would have mattered if I put the right dimensions in. It centers. There's a calibration routine that may. I kind of think it doesn't matter, because if it was that exact, I think it'd want to know how far off this thing is from my center rotation, or how far this thing is from the camera angle. It says it wants these all collinear and stuff, but I don't think it. Well, it's probably better to get them all on the same plane, because it expects them to be. But yeah, okay. So there's nothing other than that's 3 pieces. That's a coat hanger bent this way, and that's a coat hanger bent this way, and then the outer piece is. And you could. You know, make this easier, you could do this. You just take this and bend it. Just get this bend right, and then just leave a bunch out here, and then just get this bent and put these together. And then instead of making this one piece, you could bend this one to come around like that and cut it. And then the piece you bent on the outside here, bring it around. I'm just thinking in hindsight, I can cut that. And then take these two together, because going through two bends is going to be pretty stiff. That way you won't be trying to control these. These are hard distances. This next part, this last, I made this one first. And I had to put in, it was real hard to get this. I had to go back and forth and bend this to get this last leg to match that. In the end, I don't think it mattered. I would get it close. I'd get it within. After that, I'm not sure it matters. See, do you have any other good pictures? Oh, this is the original diagram. Yeah, this is wrote down 80, 70, 40, 30. Take the Pythagorean theorem and convert it to inches, and that makes that 1.968. 70, 80. Take to then get that and convert to inches. That's that. This is inches. This is inches. This is inches, and that's inches. This is the angle there. This is the angle right there. This is the angle right here. The little trig will tell you that's the angle there. So, yeah. That's what I started out with. I did put in another stiffener. Oh, yeah, and then I added, after I got it right, and I felt like it was pretty good, I just bent a piece and put it in between the two others and taped it onto there. Don't know if that's a good or bad thing. And I did the same thing on the other side. Don't know if we'll see a good picture where you can see that. I had to put the third piece on right there, or have I think here my third, yeah, I do have a third piece on it, but it just goes, this is all I cared about, being stiff. Yeah, this is how I did it. Put a third piece here, so I just have to match one angle. And then the last piece went from here to here. Since this one's so hard to do, I think I just did it right here. That stiffened up that. You can be creative. That's just one way of doing it. If you got 3D printing, you can 3D print that out. If you can cut aluminum, you can cut aluminum out and make that. You just mark points where you want to put the diodes and hot glue them on, or I would definitely solder them up and test them for a hot glue them on. I don't know if a hot glue might break it. Or you could wrap it with thread and wrap them in place. There's a million ways I can think to do. Wrap it with thread to get it in place, and just mix some epoxy up and touch it down on it, and that'll hold it in place. Squirt some Elmer's glue all over that thread. Use some hot glue right next to it, but I don't know how the heat's going to affect the diode. It can't be that much, because I did all my heat shrink tubing. I don't have a heat gun or a hair dryer, so I did it with this. So it got a little bit hot. I was very careful about not getting it too hot, but I must have got some heat into it. Yeah, this is just kind of showing how it lines up. So I guess, oh, and this is my equipment. I got the bunch of buttons there. This can also be a throttle. This can be a rudder. I think it's sufficient enough rudder for flying airplanes that don't take a lot of rudder, like jets. You do have to twist it. Well, I said earlier, I'm not real. I bought the Thrustmaster rudder. I'm not too crazy about it. I don't know which one's better. You can get. Problem with that rudder is, if I sit in a chair, it's really, you're moving the rudder by moving the muscles in your knees, where your thighs attached to your lower leg. And in airplanes, you move the rudders by moving your one of two ways. You either put your feet on the rudders, which you can brake with by moving down with your toes and move it. But for real small movements, you can just, all the airplanes I've been in, you can put your heels on the ground and just use your ankles to do it, just like you drive a car, and get real small movements in like that. And since this moves in the vertical, since your feet are horizontal to the floor with a slight pitch up of 10 degrees, yeah, it's a little bit harder to control. I'm still trying to figure out the best way to position my feet, but I just can't, and this doesn't matter for the airplanes. It probably doesn't matter even for the P-51 and prop planes. The rudder's not that critical. I have an exact place perfect, and I can always correct it back. But it is critical in the helicopter. The helicopter is very sensitive to small rudder movements, and if you play DCS, you know you can put curves in, so small movements towards the center are very, you can take the sensitivity out of it and allow you to get, you know, it takes a bigger movement to get a smaller input, which I have on my sticks and stuff. So I just instead of it just going off in the Never Land with a slight movement, it takes some of the sensitivity out at the center, but allows me to full travel at the edges. And as long as I'm trimmed up, so if I'm trimmed up, I just need to put small inputs in. But the problem if I did that with my rudders is you have to go full travel. If I want full power, I need full rudder in over here, and I need to see, and I'm balancing that. I need just a little back and forth, and so it would be hard at the edges. So I could experiment with those. I could maybe get so it's a little less accurate at full power setting, at full rudder inputs. But I've read, but I hadn't tested. And I don't know how to fly a helicopter well enough to test it, but I knew how to fly a jet when I started doing this. I don't know how to fly a helicopter. I don't know the stall. I'm learning the stall when I say stall, how you exit controlled flight, you know. And there's, I think it's vortex tip. I forgot what the word was. Basically, when the downwash is, the vortex on the downwash is coming back up to the top of the thing, and normally if that's moving down about 300 feet per second, you're moving down at 300 feet per second, and you're moving forward at the same speed it is, or speed enough to get into it, which could include tailwinds and headwinds, tailwinds more so. Then there's nothing really holding it. A helicopter, all of a sudden the whole column of air is moving down with you, and you've lost all your thrust down and you fall. The way you get out of it is you just fly out of it. You just lower your nose or turn to the side and just get out of that vortex. There's another method which is just like an aircraft. If I'm in an aircraft, they gave it complicated names like what were those names? Power settling and settling with power. And both those words means different things to Americans as Canadians. You'll hear about Canadians say the FAA is all wrong about what one of these things is. And there's a lot of talk, and one guy who's been a pilot, he's been piloting helicopters since the Vietnam days, talked about it. He said they used to call it power settling, then they called it, but there's two conditions. Well, there's really three. There's one, you just put in too much collective and you stall the thing, just like in a plane. If you just pitch up faster, if you get your AOA too high, you stall. It's just too much AOA on the rotor blades, and that's when you put too much collective in, and they call that I forgot. So that's a simple term. Another term is when I said sink rate. I got too much sink rate. What that means is, like in the T-30, it's probably hard to have a problem you got to be in a light plane. You got to really be in a stupid place to get that to happen. You got to be going down straight up. But let's say I'm in the final turn, and I'm banked real hard, and I already had 1,000 feet per minute down, and I'm just not paying attention and let myself get it 2,000 or 3,000 feet down, and I'm on, and I got the engines at idle. It's going to take me 5 seconds. Well, 3. I don't know how long it takes to go from idle to intermediate power, or 90, but it's not going to have any power till it gets up to 70%. It's going to take time for those engines to get from. Newer engines will probably spool up faster because they got variable geometry, but that engine's slow. So you really got to be thinking, do I want to pull these throttles back to idle, or would I rather just pop in the speed brake, which I can take out real quick? Because when you get it back to idle, it's going to take time to get up to 70%, and you're going to get behind the plane. So I went off on the subject because y'all don't. I need to keep this simple for you. If I'm going down real fast, this is called too much sink rate, and I've only got so much power to correct that, and the ground's 100 feet away. If I'm coming down real fast, I don't have enough power I can slow myself coming down, but I'm not going to slow myself enough where I hit the ground. And it's got nothing to do, I mean, it may have something to do with how fast you can turn and come up, but a lot of it's just mass and inertia. You got this much mass and inertia, and I can't turn the plane up enough, and even if I could on a T-38, I'm not going to get, if the engine's at idle, they're really talking about when, you know, your engine's slow enough, or even if it's fast enough. I mean, if you get going down fast enough, even the intermediate, you won't be able to get out of it. So that's really what they're talking about in the helicopter is even at max power, you've got enough sink rate that with the max power available of the engines, you just can't overcome that. So I think of that because I used to always, you know, hear about the T-38 killing people, and they wouldn't be concerned with, you know, there's lots of ways you can stall in the final turn. You can get your speed low. You can start the final turn too slow, have too big of a radius, and then at the last minute you try to correct it and pull in too much and saw the plane fall out of the sky. And the problem with all those things, and in heavyweight, no flap, and single engine stuff, these things become, there's way less margin for it. And so, I mean, some of these patterns you see me doing, I'm pulling out stuff that they just would fail me on the flight for. And correcting, coming out of the final turn just so far off from the runway and not going around where they would fail me for trying to do the landing. But I made most of them, not all of them, but and I'm not sure. It's always got the fuel thing with the wrong calculation, but I think it's, and the T-38 doesn't have neither external tanks or guns, so I think it's 145 plus 1 knot for every 100 pounds of fuel. Whatever it comes out to be, it's 10 knots for every 2,000 pounds of fuel, I think. Let me make sure I said what 2,000 pounds for every 10 knots, yeah. That would be 200 pounds for every 1 knot. Yeah, that's what it was. 200 pounds for every 1 knot, yeah. I think that's it, yeah. I think that's right. And then the final turn you do it 20 knots higher than you do. But anyway, I was talking about sink rate on. Okay, so the thing that can happen in a helicopter is, but the thing different about a helicopter is, helicopter has much less available power if it's not if it's in straight, not moving. If it's just over here, well, if it's flying, it's got the wing, the rotor's going around creating lift, and it reduces it on one rotor, increases it on the other. But it's got its flying speed, and that creates lift too. So it gets a gain. It doesn't need as much power to stay up in the air as it's flying as when it's in a straight hover. And so a straight hover, you need much more power to stop, you know, there's to stop something. Where if it's got some, but whatever it is, you know, it just means that if you let it get, if you're going down and the ground's coming up fast enough, for every airspeed you're at, there's only the perfect pilot can't recover from it with the available power of the aircraft. Just the same as a plane, if I get too much sink rate, the perfect pilot can't recover from it. And then if you put in margins, if you're not the perfect pilot, they probably put some margin in. It's just things to watch out for. And they call that power settling. But it just depends. At one time, they had a term, one was power settling and one was settling with power. And one of them meant the wingtip, the vortex. They renamed one of them to vortex tip shedding. I forgot what. I need to look it up. But it's a different thing. It's when a helicopter pushes air down, air goes down, and normally it just goes down. It goes in a vortex behind the plane. But if you go slow enough, and there's a movement like this, well, if you go slow enough, see this is moving down, that vortex is probably going down. But if you're going down at the same speed as that vortex is going down, and you're not going forward fast enough, then you're in that vortex. And if you get into it, there all of a sudden there's no momentum being, you know, there's no air coming out of that. Like the other way, there's air coming out in a vortex behind you, but this you're just in the vortex. And if you put in more collective, it just makes it worse. And so you've lost all your lift and you go down. That's a complete. So I think there's 3 departures from flight that with things not broken. And there's overspeeding the engine too, but one of them is and they have governors, but one of them is just a stall. You put in too much collective you just put in too much collective. It's just that leading thing is stalled. So and I think they call it overpitch. I've been watching a Canadian guy, and he defines the power settling different than the American guys do. And he says they're all wrong, but really they're just using different terms for different things. They all mean the same thing. And then there's that vortex thing where the vortex that moves down, when you're moving down at 300 to 500 feet per second, and the vortex is moving down normally in your aerodynamics, when you're both at the same place, then you've got no lift. You're falling. It doesn't matter what you do, you're falling out of it. But all you have to do is just tilt this way or tilt forward. He said tilting to the side's better and redisconnect, but I don't understand why. Well, it may be easier to go off to the side. You're going from 0 to a velocity, where if you're already up forward, it might be harder to increase your forward. So maybe it is better to go side, but you just get out of that vortex and then lower your nose and fly out of it, and you can recover in a few feet. And then the third thing is it's just in an airplane you got sink rates, and when you don't have enough power to get it out. In an airplane, I'm more concerned with the sink rate for where I have to take into account. If I'm in a prop plane, you press your car accelerator. It's a second or two. It goes from 0 RPM to full RPM. Maybe under load it takes longer, but it'll get up to somewhere it can make some power pretty quick. But old jet engines, newer ones may come up pretty fast, but even them, I've watched enough engines, they do take a while to accelerate. From, when I'm in the power zone, 90 to 100%, yeah, they do respond pretty quickly. But when I'm at idle, they take a while to get from idle. It's about 50%, it's 50% in the T38. I don't know what it is in F100 and F110. But I've seen them. I've been to many engine tests and watched them, both the F100 and F110. And that's the jets, the propulsion units in the F-15, F-16. And I think I know the F-14 went to a different dash number of the F-110. But I used to work I used to be a project engineer and go to many of the flight tests and engine tests and performance tests for the F-110 back in when they went to the improved 129. They went from the dash 100 to the dash 129, and my friend was doing the same parallel work on the F-100, which is the F-15 engine, and we did fly an F-110 and an F-15 and switch them around because they were thinking about making it a backup engine for the F-15, but they saved the Pratt & Whitney F-100. But I digress. In a plane, what they call, and it depends on the thing, but it's really not enough power for the mass and inertia you got going down. In an airplane, especially an older airplane, I'm concerned with if I'm at a low throttle speed, it takes time to get to a responsive power. It might be 5 seconds, 4 seconds. We're just throwing a big number. But the ground's coming up fast. And so I got to wait 5 seconds before I can get any power into it. And at that point, I've developed more sink rate. I'm at the edge of stall, or if I'm not at the edge of stall, by the time I pull and try to arrest my sink rate, now I'm at the edge of stall and I don't have power to. And that's what they call it power setting. They say mass. So that's what I think of. They always used to say, I said the word earlier, sink rate. You got to, they'd say your sink rate's too big. Your sink rate's dangerous. And that's what they're talking about. Well, they're talking about the same sort of, what they call the powers, whatever it is. You're going down, and if I'm in a hover, I've got much less available. Sometimes if my altitude's high enough and I got enough weight, I don't have any power at all to get out. You can only take the helicopter off by getting forward momentum and ground effects and coming up. But if I try to come down, I can't come down because I got the lift and moving forward. So if I'm, and correct me if I'm wrong, I'm learning how. I've only read about helicopters for a week or two. I've only got about 10 hours in that, but I'm reading a lot about it. And I do have a big aerodynamics background, so I do know. I mean, I know enough aerodynamic equations. My goal was to write a flight sim myself, so I know I've had aerodynamics in all the courses, and I know rotations of quaternions, and I know the aerodynamics of airplanes. But anyway, let's get back on subject. So in a helicopter, I'm coming down fast enough, and I don't have enough power to stop it before I hit the ground. Or if I'm moving forward, I have to be going faster because I do have more power available. But still, there's a point where at my altitude, the recovery for that, I'm just not getting enough power. So it seems to be and just the typical airplane, I just get my AOA too high and I stall, and the cure for that is I lower my AOA. And a helicopter, you put in too much collective, and if you recognize it and pull it out, the solution is take out the collective. And both of them you are going to lose your nose comes down, you're going to lose a hair of altitude, but once you're flying again, you come back. The same thing, and you gain airspeed, and the same thing with that. So they're all the same thing, but the terminology, it seems like the Canadians being one thing with what they say, and then the U.S. military used to call power settling what the one with the vortex sheet, or I don't remember the terminology and who's doing what, but they used to call it one thing, and then they came up with that term, vortex, tip, stall, something. It's really talking about when that vortex is moving down at the same speed you are in 3D geometry, and you're flying in it. When you're flying in something, the helicopter creates this, but it usually goes behind the helicopter. But if you got a downwind and this thing goes down, and you're dropping at the same rate it's going down, you're flying in that. When you're flying it, you've got nothing to make lift off of because you're flying in a downward field. So you're just going to keep going down with it. So, and they used to call that power settling, but they've changed that term. And it seems like Canadians kept it and Americans did. And if you read, and they say the FAA calls it wrong, but it's really, I think they're talking about all three, and it's just they're using different terminology for it. And also, the term has changed what it means over time, because they used to not call that vortex, and then they added that and replaced that in the whole military training. That's what I understood from reading what this pilot, and it made complete sense to me. So anyway, so the whole point of that was, if you were to talk about airplanes, I know all the conditions for going out of controlled flight. Now I don't know how to recover from an inverted flat spin. I know how to recover from a spin. I assume inverted, you'd be the same method, but I would guess, it'd be a complete guess, is that you do nose back, replace the nose up with nose back, and the opposite rudder and the power out. But I don't know. You may, jets are hard to get out of flat. I don't even know. We were taught not to get in a flat spin in the 38. We practiced getting in spins on, the non-swept wing 37. We practiced them all sorts of flights. And, I've got the P50. They're pretty easy to get out of spins. And I guess the jets are different, but I don't know. But there may be ways to get them out a lot of times, because I got test pilots and they do that. But it may be just in certain regions of the envelope they're hard to get out of. I don't know. But they don't go into spin either because they don't have the P factor. Well, they do, actually. You just got to kick in a rudder. But kind of talking about things I don't know about, because I hadn't done them. Okay. So we talked about that. Let's see now. And you can, if I get off on a subject, you can hit fast forward if you're watching this and trying to figure out how to build it. Just hit fast forward, because I did go into some other subjects. Okay, so you can build this mount. You can use a coat hanger method like I'll use. If you get it close and you want to extend the end, you can use plastic straws and kind of get it there, and then put your wire in the right length. And once you use a coat hanger, space it, put it in the end, look at your pattern, put it on. Once it's perfect, hold the wires in the perfect place, put some electrical to, and it's got them fixed in that length. So that's what I did. But you could cut the part out of wood, cut the part out of aluminum. I wouldn't go anything stronger than aluminum, take forever to cut. If you can 3D print, you could do that. If you can find a 3D printed one, they will get here in less than 3 months. They are made, but I didn't see available. You can get that. And then I think Della makes what I'm making here for like $50, maybe $40. So it may be worth it just to buy one. Maybe $60, I don't know. It's just, you're gonna have to pay. Dillon is a British company, so I don't know if any American companies are making one of these. But what were the parts? 5, 10. See, for the clip itself is 5, 10. Some gel sheets. $17.50. It's $20 plus just stuff you got laying around. I mean, am I going to put a cost on solder and electrical tape and coat hangers and plastic straws? I don't know. It's $17 for the clip and $30 for the camera. That's $57. I think you can buy the Dellin clip for $60 with a camera. I'm not sure if it's with a camera or not. Let's just look and see. As long as I'm taking the trouble to do this, let's just see. Dellin. I mean, track IR. Let's hope I spelled it right, or close enough to. Okay. If you're in England, you can certainly buy it. It's going to make more sense to buy this than build it, probably. Especially if you buy the parts from American eBay and get them shipped over there. Products. So I think this is without the PlayStation camera. This is exactly what I built. So what's the price for it? This is what I built. That's what I'm saying. You know, I use coat hangers, but you could use. This is exactly what I built. So how much is it? So how much is 24 pounds? I don't know what to pound to. Oh gosh, British. Pound to US dollar today. £1. Oh man. Okay, so you could probably buy this. This isn't that expensive. Shipping may be expensive. Okay, that's 1 1/3. So it takes $1/3 more dollars. Somewhere between $1/4 to $1/3 more dollars. So I don't know. I had $33, $10 shipping, $43. So the clip's somewhere between $35 and $40. And he gives you some gels to put over your camera. And then the deluxe kit, I bet, includes a camera. Oh no, the deluxe has got that with batteries. So you can do this with batteries too. You know, and just charge up, put in. You know, you can do that with batteries. Oh, and in hindsight, I actually did do a switch, but it broke. Yeah. I soldered on a switch. But then after I got soldered on, I tested the switch and it broke after I put the heat shrink tubing on. I must have got it too hot somewhere or something. Or I think I had this in vice grip, so I may have broke it. But I ordered this from eBay, so here's another switch. So I just put this on, and then I don't need to plug and unplug this, you know. They say not to plug this into your computer. You could destroy it, but I think I don't think you're going to destroy it if you insulate the red. If you keep your amperage where you're supposed to, it should be deliver that much power. Even USB 1, I think, could do 500 milliamps. It can certainly do 100 milliamps. I think. Look it up. Look up what USB plug you can put up and see how many milliamps it can do. And I think those signals on those things tell it when it can go up to 2 amps and 3 amps. So as long as makes sense. If you're an electrician, tell me if I'm wrong. So if you've blocked there's, in addition to the red and black wire, which is power, there's a green and a white, which is carrying serial connections. So if you block those off, make sure that they're not going to get positive voltage or cross connect to the ground. And you're keeping your amperages low. I don't see how it can hurt your computer. but people say it can fry a motherboard, so don't plug it into plug it into a plug-in wall thing or something like that. So I did to be safe, but I think that's just people saying if you screw up your circuit, then you could fry your motherboard, which may be true. So that's the Dell clip, and I think the Dell Gamer, does that include a camera? Yeah, the Dell Gamer. So this is all the stuff that I got. So how much is it? It's 44, so let's add a third on to it. 22, 46, 66. So we're up to 35, 45. Gel packs. He gave you the 45, 45. We're at 52. That was 66. So yeah, if you're in England, just buy it there. It's a difference is $10. I mean, if you shop these carefully, I have not shopped these carefully. But you can, if you can find this thing for, if you're in England. If you're in America, you're going to pay the conversion rate. You're going to pay to get it shipped over here. So, but it's not going to be significantly more than the parts are. But again, if you look around, you can buy the camera for $5 somewhere. Gel packs. That is colored plastic. You could probably find that somewhere. I mean, it's got to be $2 a part, less than $1 worth of parts. Obviously, those diodes, they would send you twice as many. There's diodes and resistors. They send you 3 times as many for 22 cents more. So, it's just the cost of the order. The cost of those is somewhere that you can find them cheap. But I was more concerned with getting them today, not in a month. But so you get the price down. I mean, I've heard you can build a clip for $20. So okay. So you'll need some Velcro or some and these alligator clips are temporary. But you need something to clip it to a hat or clip it to your headphones. I'll probably in the end clip it to my headphones, but I really like these headphones for being so light. I've got zillions of pairs of headphones and I hate them all. And I do like these. I may, if I put magnets on these, it'd probably screw up the speaker. Well, I have to think about how I'm going to clip it on. So for right now, I'll have it kludgy until I think of a good way to put it on my headphone. Or a headphone, or I have another set of headphones that I could use to hold the clip. This just got one ear. I can maybe put them both on. I don't know. I'm going to think about it some before I do permanently do it. The camera we talked about. The filter we cut out. Cardboard. Empty toilet bowls. I can show how you do that real quick. Yeah, let me show. I wasn't that clear about it. Let me make sure I got my scissors somewhere. I gotta find my scissors. Give me a second. I'm going to take this thing off and look for my scissors. Those are shitty scissors. There's this pair of scissors, but they're terrible. Yeah, I've got thousands of pairs of scissors, and I can't find any of them. But I mean, I only know where they are. You want to know the quantum theory for the placement of scissors? The half-life of the position of a pair of scissors is got a 50% chance times the square of the number of minutes since you last knew where they were, or number of days. I'd lay them down and who knows where they are next. But anyway, I'll show this. These are some other scissors. What I'm showing is you can just make little cuts like this. I mean, the way I did it was I took the bottom of it. I said, and I wrote down and took a pen. So I did it. I mean, the easiest way is going to be to find something a little bit bigger than the the PlayStation camera, but I couldn't find anything, so I just did this. But I just marked this top where this dot is, right there, and I went around to the back side, and I just bent all these down. And I was thinking, when I did that, maybe I didn't do as much bent down. I bent them down a little less, so it was smaller than the thing. And so then I put my gel right over this and just taped it on. And then I took this part left over and cut that off. I cut that off. So now I've just got tabs on the bottom side. I put the gel. Why did I feel the need to put on the bottom? Don't know. I mean, in hindsight, probably make more sense. Well, this is how I did it, so it's probably the wrong way. I taped it onto this, and I taped it up here on the top. And then I started taking a square piece of gel and doing the opposite. And just, as I cut those tabs there, I just cut into the circumference and created little tabs and bent them, and bent little pieces of gel down over this edge. But I knew I was going to cut this to a certain thickness, so after I just put enough tape on to get it in place, because I went back and cut these off later. So I need to be more clear. So that's how I did it. But you'd probably be better off just to take your gel right away. But I gave you the concept of tabs. Just lay it, cut it a bigger circle of gel. An inch. Give yourself some room to play with. Make it an inch bigger, round it, or half inch, and then cut radially around the gel. Just cut one of them and tape it on, get it in place, and go to the other side and get taped in place, and then just go around and cut it and tape them down, and you made it. And then after that, if your pieces are coming too far down, go back and cut them all so they're only a 1/4 inch bigger than the tube, and that way you can cut your whole tube a 1/2 inch or reasonable size, because you need some space for the tape between the gel, and it has to have some area on your tube, and then you have to cut the tube off. As in, you can't have your gel come down to here and have a nitnoid millimeter of tape holding it to the paper. You have to have a good, I don't know, 1/4 inch, 1/3 of an inch holding it to the paper. That's as much as you can cut your tube. And then cut your tube off right here. And at first I was going to put other pieces of tube in to make it smaller to fit in there, but I got tired of doing it. I just put it in there and scotch taped it up there. And scotch tape will probably always hold that to the PlayStation camera, but when I get my mount, the mount will put it on the monitor. So that covered how to make, but the key is you need a tube bigger than the camera, and then you need to somehow attach that gel to it, and you can be creative with it. I've just shown you how I've done it, and I did it all in a 1/2 hour with no planning. It's just whatever I could do quick because I want it to work. So I'm sure if you thought about it for a long time, you get it better. I already thought of how to do it better than I did it. I was just trying to make it work quick and kind of working it along as I did it. So, okay, so that's that. I can show a picture of my equipment real quick. This is well, you saw the picture of the stick. I mean, this is a stick. This is made by, well, I can't get it to the, I'm running out of wire. That's the stick. It's got these buttons over here. I've mapped this as a modifier button. I mapped one button on the other as a modifier button. Now is what is going. So all these other buttons, it's got a button here. It's got a button here. It's got 3 hats on top. It's got 3 hats over here. Hat, hat, hat. There's a side button here. Thank you. This is another axis command. This is Yeah, I think that's why it doesn't have as many buttons as a throttle. Lots of people don't like the throttle, all these little toggle buttons, because they're not on the HOTAS, but I do, because I can map. I've got my gear on one. I can, in a real plane, you have to take your hands off the things to pick up the gear, so I can just take my thumb and hit that. I could probably hit all these bottom buttons up with practice, and I can hit one button over here, practice up. But I have things on like engine start, engine shut down, commands like pause, time speed up, just convenience commands. I might put escape on one. I don't know. So I don't know. I could go into more stuff, and I went off topic. So I'm going to take my picture down and think for a second if there's anything that I didn't cover or anything that I said wrong. So I'll take this picture down. Here we go. So all that's reading. It's fitting on the screen pretty good. Let me think. And I may come back and do some helicopter flights in a second. We'll keep this on one subject. We won't have it be 6 subjects of stuff. So, diodes, resistors, USB cable. Oh, you can use rechargeable batteries. You scale down your parts or do the electrical calculation. I got some 4.2 rechargeable batteries and a holder for them. So, my resistor is probably a bit too big for that. It'd take my light down to 50 milliohms. But I could put 2 in parallel. I forgot. It's been a while since I did it, but if you have a handy rule is when you do the inverse relation of sum of resistors in parallel, the number of resistors in parallel seems to reduce it by n. So if I got 3 in parallel, it'll be 1/3 the resistance. If I got, and they both calculated out that way, and the algebra showed it, so it seems to be true. I don't know. Build ways. Search the internet for it. There are some 3D mounts of it people made. You might be able to find an American copy of the Delling clip that's a little bit cheaper. I thought I saw a kit for $60 on Amazon or somewhere. And I definitely spent more than $60. I don't think I spent that much on the PSE3 cam. Amazon. I don't really want to show them. Well, I've already shown y'all the joystick I got. You can look it up and see the price of it. By the way, it was about $400 for that joystick, and the rudders were. But there's a lot of others. There's some Thrustmaster entry ones that are more than enough. I think the next one down's only got 1 throttle. I don't think I've done anything where it's required I need 2 throttles. It makes it a little bit easier on precise power settings. You can kind of inch the throttles down one at a time, but you can do 1 slider. You do want a slider that stays in the same place. I mean, you can use an Xbox. You could probably get by on an Xbox controller pretty well. PlayStation controllers at the limit, because the 2 bottom triggers on the PlayStation controller, when you plug them into a PC, it sees those as buttons. It doesn't see them as axis. When I say axis command, I mean you pull it a little, you get a small value fed to it. You pull it a lot, you get a big value. Just like your joystick controllers, your axis commands. And I believe the Xbox controller, so you could use that for rudders or brakes. You could use it as rudders and then put wheel modifiers. You can modify it to be brakes or use your top things, or do it a lot of ways. that'll free up an axis, and then you could use. I was almost, yeah. Then when you did that, you wouldn't have to have your rudder on your right. You could do full view on that, so which would be really helpful. That could get you by for a long time. And then just tie your throttles to, since there's no slider on an Xbox, I really don't want to put I don't want to put the throttle on something that returns to center when I let go of it. And I don't want to be holding it up the whole time I'm flying it, or holding it in the right place. So I would rather adjust it. I assign it to the back buttons, and the granularity of the adjustment was terrible. I couldn't do pattern work. Well, I couldn't fly a T-38 accurately. I didn't. And you can bring up the control box, which you couldn't see my pictures over, but there's a little box that'll show your controls on DCS. And it's helpful, especially if you're using like it'll tell you how much throttle you got in, because you don't have a clue when you're just hitting buttons, and you can't read that. And I think there's a command that brings up that box out on the bottom that showed all my airspeeds and stuff, so you can do that. DCS is free. I mean, DCS is free, and you get the TF, the P-51 without guns, which is fun to fly. I'm just not flying it because I just think about my flight school days, and I love the T-38. So the F-5 is the closest thing to it. I didn't, when I was talking about, I talked about Hellcats over the Pacific, but after that I played F-18 forever, and it modeled, and it didn't feel in some ways as accurate, and it did, but I think some of that's its modeling to fly by wire. I don't think the real plane feels. I think if I was to get out of a T-30, well, I know for a fact, I mean, because I know how fly-by-wire works. It does what you want to do, what you want it to do, not what the airplane really does. So it makes sense that, you know, everything would seem all linear, and it just didn't seem. I think that it auto trims. I'm used to always trimming up for conditions, so yeah. And so I did that. I did the A10, and this is back in the flight school in '87. That's when they didn't have dual track training. So I was doing this from '88 to '95. Probably by the year, a lot. Yeah. And by the time I moved, I don't even think I reset it up. I just sat in corners. Yeah, but yeah, I was doing F-18 with a full thrustmaster HOTUS, and then I did A10, and then it's so much trouble seeing the views. That was the problem. You're in the cockpit looking straight ahead, and A10s felt pretty real. It felt like an airplane. It felt like a real airplane. F-18 did, but it felt like a fly-by-wire airplane. I mean, it did, you know, I used to look at the turning rate, and this is definitely the C model. I mean, it wasn't the Super Hornet. There wasn't a Super Hornet then. But I looked up and did some guesses on the best turning rate and turning radiuses, and they seemed somewhat accurate. I mean, I'd go in and whatever artificial intelligence I would dogfight, I would out-turn rate them, you know. If I kept my knots at what it should be, and I think I used vertical yo-yos, and you know, and then this is before I knew the name of the maneuver. They hadn't given it a name. They called a missile's fired at me. I want to get my angle off big enough to make it go further. I mean, Shaw's book goes how to avoid missiles in detail, and other stuff too. You keep doing turns away from the missile and make it fly further, and you're kind of turning off its perpendicular. But there's another goal, is if you got a missile in the air. The AMRAAM was just in development then, and I think they had AMRAAMs on that sim, but you only have a limited number of them, and it wasn't the new AMRAAMs, the old ones. But so if you need to keep but you may want to keep radar locked to know where he is, so you don't want to turn off enough to lose that radar lock. But if you can keep him in your eye, I mean, I don't think You know, there wasn't a DCS forum back then to read about all this. I mean, right now, all this stuff is out there for you to read. You learn everything about aircom. Back in 1990, you know, I bought Shaw's book. I bought another book on fighter pilot tactics. I was in the Air Force. There weren't a lot of pilots. I didn't know any pilots that were in. I knew pilots, but I didn't know, like, F-16 fighter pilots that I could talk to about this stuff. And the ones I did know, you know, there's a distinction between they're not going to talk about classified stuff, anything about their envelopes and what their best turn rate is here, or their tactics or things like that. They're going to talk about basic World War II tactics, not. And so they're probably going to hold back stuff when they're in doubt. They don't want to be, you know, unless they're your best friend or something, you know. But I didn't know that. I had read a lot of books on it, so I did that. And it just got is getting to be such a buttonology, and I couldn't map. That stick had about 5, it had 4 commands on the throttle, maybe 5. I don't think it had a hat, but it did have a rocker that let you, but then that was confusing. You could use that as a modifier, but you'd always get confused where the rocker was. And then the stick had about less buttons than this stick has. It had a trim button. I don't think it had another hat on it. I think it just had the trim button. And I think it had a trigger and another button. Yeah, I don't even know if it had another button than the trigger. Maybe a trigger, another button, and that was it. I don't even think there was another hat on it. So I was definitely limited on buttons. There may have been 2, but oh, and there's a thumb button too. I'm pretty sure there's a thumb button. It could have been a rocker, but I think it was a button. I think there's a thumb button, a button next to the trim button, a trigger, and there could have been a nozzle steering button. I can't remember. It wasn't a lot. It's about 4 or 5 per. There are probably 10 total buttons on it all, in one hat. And the throttles, I remember having a button for each digit and a rocker on your thumb, and maybe another button on your thumb, maybe not. The rocker could turn 7 or 8, 10 buttons into 30, but the rocker was very confusing. I generally put things I didn't use off on another button, and when I did use a rocker, I'd forget. It wasn't a return to center rocker, so you get confused where it are, you know, and if it's in the wrong place, you think you shot a missile, but you actually didn't do anything. So, and when I went to software, I did route planning. One model, I can say this, one is in classified. One model was just line of sight. It just reduced your line of sight. And let me think about how I can say that. Okay, we made route planners, and they found the optimal paths for a certain cost model, and you're trying to minimize your cost. So if I want to drive from Tennessee to California, and my cost is the distance, and I want to minimize the distance, then you can do a search algorithm, Dijkstra's, ApeStar. Ours is Dijkstra based, and find the minimum distance on roads. Draw networks of roads, and nodes are cities, and roads connect that. Each one has a distance. There's a way to search that optimally and find the minimum distance between them. So that cost model of what I described be distance. Well, you can make it more complex and be aircraft and do different altitudes and velocities. And then you can have, we're going to reduce your line of sight. You're just going to put out where are the radars at and where the mountains are, and just the least number of detections of line of sight. You know, try to minimize that. And then another one cost model we could have would be stealth. And I really can't talk about that other than you're just going to minimize your stealth return. So we did that. But in that, I had an F-35 simulator. I don't know how accurate. I didn't. That was That was 2002. So the F-35 was in its young days. So I guess that was just the avionics, because I imagine all the performance of it was classified. I don't know why they would, if it would have been accurate, I don't think they would have let me. Well, I wasn't in a classified area. Maybe it was accurate. I don't know. It seemed underpowered to me. I mean, and so I didn't believe it was real. It seemed very underpowered. But that was the F-35. And I was flying with the mouse and keyboard, which I already talked about. Flying with the joystick's bad enough. Trying to fly with the mouse and keyboard, you can't do anything precise. So, and the purpose of me doing it was not to learn to fly the airplane, but is to evaluate it for integration with our route planner. So there was no need for it to be accurate. It's just a flight sim they had, and we just had to link into it in a couple places. So its performance, that was just a perk of the job. And then I worked in another group that did simulators, and I was surprised they didn't use quaternion math in their simulator, which I had access to the Wright-Patterson Technical Library, which has a lot of technical information in it. And there's a book on simulators, and you use quaternion math to do that for a number of reasons. It's faster, it doesn't have singularities, it's more accurate, and it's much less math. It's just the multiplication is less than a matrix, and so yeah. So, but I think they were using trig. I think they were using trig stuff, and with a few matrix rotations. But anyway, that's what this simulator group, they did everything wrong. Using that, they were doing flat space. They weren't doing in our route planning, we did all Earth-centered on a spherical Earth calculations, and did our calculations of that, and then projected that onto the route in flat space. But the calculations were done in all Earth-centered proper rotations. But I digress. In that, I got to land I got to run both the C-130 and C-5 simulators. A C-130 has a heads-up display, so I landed that first try. Once I was in Huntsville, they had a space shuttle simulator. I landed that first try, but all of them had, I mean, for me, it's got a heads up, and I'd had a lot of time at F-18, so I knew how the velocity vector worked. But when you see me doing those T-38 patterns, I have to be evaluating all the time, what is my trajectory? And yeah, if I can look at the screen for 5 seconds and see what's moving away and towards me and stuff, I can figure that out. But it may take 10 seconds, it may take 2, depending on how familiar I am with the airplane and the throttle I'm at. But it takes time, and the way you get that is seat time. At certain throttle settings that at this throttle setting, I'm probably going to keep level flight, and when my point's here above the canopy, then it's here, and you start learning to look at this point, it's even with here, and you just learn all that over time, and then you learn. But if you've got a velocity vector there, it's pretty much just, and velocity vectors in a HUD, it's that little dot you see move around. That's where you're heading if you stay on this path. Now, it does have lag, just like a VVI, or it did in the older planes. I don't know why. Maybe newer ones it wouldn't, because the computer should be infinitely fast in them. But you just point that where you want to go. Look at your airspeed. If it's too high, take off throttle, and it's pretty easy feedback loop. You can just look at that and keep it pointed while you're adjusting your throttle. There's no, and maybe it's the fly-by-wire of them, but there's no interaction between the throttle. You don't get those oscillate where I'm in a T-38. I'm always, okay, now if I take out power, I'm going to come down, but I need to be evaluating this and what's my, and where am I headed actually, and all that. So until you get a lot of time with it, you just, and I don't have any time any other so yeah, it took me about 3 or 4 tries to get to C5, because it didn't, one of them, I think it's the C5, didn't have a heads-up display, but I think it's the second time. I think the first time I did crash it landing it. But that's a big plane too. That's like landing a 707, and it didn't have a heads-up display. And you're way up high. I mean, that's as high as a 747. I think the second time I landed that. Yeah, so I've got some time in it. I'm actually surprised I'm not flying this F5, but the pattern's hard. The key to the pattern is when you call out for a clutch, it's probably easier if you're coming in level at 1,500 feet. Then you just make a level turn and you're just going down from 300 knots to 100. But the key is when you get out of that turn, you're trimmed up and at the right altitude and the right airspeed, or you're close. Your deviation, so you just need a small correction, and you got your gear down. And definitely by the time the perch is 45 degrees off from the end of the runway, that's where you're going to start your final turn. At that point, the plane needs to be flying at trim conditions, and you set up, and you need to have in your mind where you're going to do the final turn. I'm going from, I think it's about a 60-degree turn. I know I'm keeping it in the green. I don't remember what, maybe 1,000 feet per minute VVI. I don't remember. But the VVI is not real. It's not a steady. You can't read anything instantaneous from it. In the T-38 at least, it's got a 4-second lag in it, so it just shows you trends. In steady state, it shows you your vertical velocity going up and down. I wonder if I should be talking here, because I'm just making this. What am I got questions in the chat. Okay. So let me answer those. I'm flying the Huey, the F5, and the I've got a little P51 time. I bought the what is the Flying Eagles collection? It's got a simple F-15 model, I think an A-10, and a couple of Russian planes, the MiGs 29 and 27 flanker. I've got less than an hour, maybe less than 15 minutes in each one of those planes. I don't know what time that question was asked. Funky Chris asked, what am I flying in DCS at the moment? At the moment, I bought the F5. It's about a $50 module. And I bought the Huey. I want to learn how to fly, and I'm teaching myself how to fly a helicopter. I've never had instruction in my life on helicopters. And it flies with the same physics, as in blades, airfoils moving through the air. But when you put it in the system's completely different, helicopter. So I was talking about what the parts flight and stuff. I did some time reading about it this weekend. So I'm just talking about now what some of my flying experience is. So I don't know. I used to play that F-15, the F-18, and the A-10. I don't know if I got 500 hours or 2,000 of it. I played 3 years of doing nothing but that. So I didn't log those hours, but I did a ton of it, So I could probably, I can do stuff like low level flight. What transfers over to DCS now? I can fly low level pretty good. Probably not with my head out of the cockpit, because it's a little bit harder to get your head out of the cockpit. You couldn't controllably get back in and out of the cockpit with only 4 keys to bind to. You were going through. You just didn't have a lot of keys to bind it to, so you pretty much had to go up this way or over this way, and so it's always up this way. So most of it was looking straight ahead. There wasn't, like a real pilot. They can be looking over here and be in a 45-degree bank and be just above the ground and be not getting too departed from normal flight, So anyway, so you asked what I'm flying. I'm flying a lot of the F5, it's the guns variant. I think they put a little bigger engine, but to offset that engine thrust, it's got a little more systems and armaments. It's probably got about the same thrust to weight ratio. I think it's probably got a little better. I think it's got those front strakes, so it'll probably pull a little bit better angle of attack, which would be good for your instantaneous turn radius. There's two things with planes. There's your turning rate, which in a turning fight is going to make you come around someone. You can have a smaller turning radius, but if you can do it at a higher velocity, I don't know what the velocity, I think it's higher velocity, v squared over r, then yeah, you'll outturn them. Your rate of turn rate is theta dot. So yeah. So at outer radiuses I have to go much faster, a little bit faster. And inner radius I have to go. So it's a function of those two things. But then if you're in a fight and you're, say I'm back here, he's up there, to make a gunshot I need to lead him for my bullets to come down. So that would be your turn radius, and what affects that is your min turn radius, and then what they call your angle of attack, which is your, if I've got a huge angle of attack, if I can do more angle of attack, even if I lose a lot of energy, I can pull up for a second and get that gunshot off, snapshot him, and then come back and before my energy comes back. So so that's some basic fight maneuvers. But I watch these guys, they're really good. You know, some of them have been doing it. There's a couple guys who've been doing it when I first started doing it. I quit doing it, and I always thought about getting back into it, but I didn't want to. I knew I'd end up buying the throttles and all that stuff, and but yeah, it's fun. I mean, I can go up though. When I was doing a lot, I got out of flight school and I flew the T-38 and went up with a friend in a little 172. We did some landings. People say you want to finish up, and I had enough hours. I just had to get about 20 hours cross country and with a private license, because I had 190 hours in jets and 15 in props. I was like, at that time it was about, excuse me for coughing, getting over a cold. At that time I think it's $50 an hour. I don't know, it's gone up. Like before I went in flight school it was maybe 30. Maybe it's 50 then, maybe it's 75, I don't remember, between instruction and plane rental. And the type of planes I'd be renting would be 172s, you know, little single engine, simple system planes. And he took me out flying. I didn't tell him this, but I felt like, you know, do I want to pay $75 an hour to drive around a Volkswagen? When I used to get to drive a Maserati, you know, or drive a Ferrari. I mean, it's just, there's not that much thrill in it. It's just, there's tons of time. If your pattern got messed up, there's the plane, you got so much margin that if you couldn't land a thing, then you just didn't know how to fly. I mean, at my level of experience, there wasn't any challenge in it, you know. And so yes, I didn't pursue private, and I'd probably be more interested, although it costs a lot more than doing a helicopter, and that I don't know how to do it, you know, and I'd learn something, but I don't think I'd learn. I know basic instruments. We were learning in our contact. We were also learning our instrument ratings. We were learning all the procedures for instrument flight. We were learning formation flying. We were learning navigation. It's instrument and they call it instrument and navigation. But you know, when you pursue a private pilot, it's all VFR, and the rules are. The VFR rules are, you know, you stay away from clouds, and you tell them about, you don't have to fly precisely. You have to be safe. You have to fly precisely enough to be safe. Military flying, you're always flying plus or minus a few knots. I think it's 5 knots. You know, 200. 5 knots, and I think it's plus or minus either 50 or 100 feet. I think it's 100 VFR and 50. I mean, you're flying precisely, which you didn't see me doing in the pattern earlier, but you know, I'm out of practice. I don't know that plane, and you know, these things are hard to do, and you don't have the cues. You don't have the cues of G. You know, the way we did is You know, I was saying in a level, if you fly 1,500 feet over and come in to the down leg, we don't do a cross pattern. That's too easy because you want to get traffic on the ground in the military. You come over the runway, brake, a high G brake, come out at the right place at the right speed, and then go downwind. So you break that whole crosswind time. And then you don't get the time, the luxury of going across and glancing at the runway and making sure everything's right and planning your descent. You do another final turn and you have to keep that. And this is where it's hard to do in a sim. And this is why this Headtracker is going to help. Because when you're doing that, what you're doing is you're setting up your power and then you're looking at where the runway is. But when you're in a sim without a Headtracker, you have to do views over and back. And you just can't get back and forth fast enough to monitor your air, and you just screw up, you know. But with, you know, either virtual reality or maybe this headset, you can keep track of what it is and where you are. And, you know, I am starting to see that where, you know, it's a view thing. You have to be looking at that runway. You have to see if you're, and, you know, these are memories from 30 years ago for me. So over 35 years ago. So I've forgotten. I'm relearning all this. So yeah, I know the basics of pattern and stuff and some basics, but I'm relearning a lot of this stuff. But I got the background, so I can do it. It's something to do. So anyway, so I guess I need to put this. I had random thoughts about flying, but I'm flying the F5 because I like it because it brings back me. I mean, it's a little cheaper. The F18 would be, I think it's $80. The F5 is $50. But it's a simpler system. There's a very simple radar in it. Although I know about how to do sidewinders and sparrows and AMRAMs, but AIM-9s, AIM-7s, and AIM-120s, but I don't know all the. I've forgotten all the radar modes and all the. And that's just from sim. That's just from what they copied. I mean, there's a big book that explains it all in that one. That was back when you bought software that was expensive. You got books and manuals, and I had it laying around there somewhere. I'll bring it back. But if I buy that, I'll use that for reference. But it had all the different radar modes and all the different tracking. But there's a lot of buttons you have to map to everything and everywhere to get that working. To better do it in combat, but you know, but it's a lot of a missile fight. You know, I mean. You can do air to air, but anyway, the F5 is really easy the systems are pretty easy, what I'll say. And the only thing the F5 has, T-38, they got automatic flaps, they got center line, they got, I don't know, the T-38, I don't think it has any tanks. I don't think you could put tanks on it if you wanted to. But yeah, I could be wrong, we may just never done it. But this has tanks. Center line and 2 externals. It's got 2 sidewinders. It's got a very basic radar. It's got a radar warning receiver. Very basic radar that tells you where the other plane is. Although you got no radar guided missiles, it's just for situational awareness, I guess. That's, yeah. I mean, if it's not guiding a missile, that's all. That's all it can be for. And it's got sidewinder. It's got a gun. What else does it have? It's got leading edge strakes, which they put. Northrop came up with that, and then Northrop designed the F-117, which turned into the F-118, and the F-5. But they put on the F-5, which later became the F-20 that's never sold. Which would have been a good plane for the money. It's very. The F-5 are right. They're still flying the T-38 and F-5 just because they're so cheap to operate as aggressors everywhere, and red teams. Just because the plane's so cheap to fly. I mean, it's now modeling 60s, and it's somebody's doing F-14 against F-5 and saying they're comparable. That's designed in the late 50s. The F5, the first F5 and is upgraded since then, but it was, You know, the T-37 was they did design that after the World War II. It's avionics or World War II avionics. A little better, maybe early 50s avionics. But it's got a huge cross check of over here and here, and they took out of the T-30. T-30 had a big horizontal over the attitude indicator. I think your ILS is on that too, and maybe some. And the HSI had a little more. It feels like this doesn't have as much info, or maybe it's just the gauges aren't big and in the middle. But or maybe it's just in DCS. You know, in real life you can look, and when you got young eyes, you look down, you can read all the stuff on the instrument. Now I look down, I have to zoom in to see it. So yeah. So what else does the F5 have? It's got they upgraded the GE engine to a little more thrust, but then they added the weight of the radars. It may carry a little more fuel too. And they added the weight of the radars and the gun. So, you know, it's kind of like you look at the F-16A model and C model. The C model's got an engine with more thrust, but the C models, they added these, you know, went from sidewinders only to shooting radar guided missiles. That when they put all that stuff in it, it really didn't have a better thrust to weight ratio. I don't know the history of the F-18, but it might probably similar going from 17 to the 18. So yeah, so I doubt it's got that much better of a thrust to weight. It might be worse, it might be better, I don't know. Might be the same. And you know, some of that depends on just where you are in your fuel state. Well, it all depends on where you are in your fuel state. And then most of the time you'll be flying with a tank, so it's going to be much worse. You know, most of any air to ground or lots of the missions you're going to have tanks that you're not going to be able to drop and stuff. So at that point, your thrust to weight ratio is gone. You're like a T-38 at that time, you know. So yeah, so they're very similar. So, and I used to fly. The one thing I did like about the Microsoft Flight Sim was the Learjet had the same engines as the T-38, and so there were books where one guy talked about these, and they fly similarly, you know. So they did a little bit similarly. I don't know. I did notice one thing. Now I don't know how well this is modeled, but this F5 punch through transonic, it went, I get that up to 1.4, 1.5 Mach. You won't get a T-38 that fast. But then, when I think about it, if you got more weight and you have more thrust, a little bit of weight, you're going to burn fuel down. But more thrust would get you, once you're through the it's like the T-38 would go through the sonic barrier, but after that it had no more thrust to push you past it, although the drag is behind you. It's really barely out of transonic, if any. But this thing, you know, you leave an afterburner at altitude, and you'll just see that it'll be at 1.4 or something like that. T-38 never goes. I mean, they took us up, and we did one supersonic flight, and you know, we lowered our nose just a little bit to go through it, and then we were just barely above Mach 1. And then we can't. It's just to show us it does it. That's the only time. So yeah. So anyway, I've talked about the F5 forever. Also fly DCS. I've got the Huey. I think I bought it off a whim one day last week and just been. I'll try helicopters, and since I've never flown them, it's like a challenge to me. So yeah, so I'm doing that. Like the P-51, I hadn't gone since I got my stick and stuff. I really hadn't gone back and flown the P-51, but I like that. But that doesn't have guns. I've went through 2 of the training missions on the a few of them on the. I hadn't done many of the training missions. I do learn a lot when I do them. They're just a pain to do, but I did when it was brand new. I did the P. They call it the TF-51, and it's like a civilian version without guns, whatever that means. and then you have to buy the plane to get a version with guns. For I don't know what the price is, but it comes with a P-51 and a Russian plane. I think the Frogger. I think it comes with the plane that's the Russian counterpart of the A-10, but it's got swept wings, so it probably goes, and I don't know, this is all, I just looked at the plane to see it's got the same similar mission as the A-10, but it's got swept wings, so I figure it probably goes a little bit. The A-10's a slow plane, but it's a great plane. So, but you know, it's got the just more armaments, anti-tank type of gun. So that comes with it too, free. So there's 2 planes that come with it. And then there's a pack you can buy, or you can just buy an F-15. There's a cheap F-15, a cheap A-10. I think all the others are Russian planes, MiG-29, MiG-27, naval version of the MiG-27, and some other plane that's Russian. And what else I know about DCS? I think parts of it were developed in Russia. Parts, the guy that it's like, I was listening to a guy talk about who's the president now, and I'm thinking it may have been like a little sim and they pulled it all together in a combat environment. And this is just, I'm not sure. I don't know the whole history of DCS. I just watched some YouTubes and it looks fun. It's a combat simulator though. I mean, I'm flying planes in it, but I see people all the time. They like go off on campaigns where we're going to recreate rescuing these hostages from here, and they'll have an alpha and a C team and this team, and go off and hit these objectives. And I saw one of them where they were rescuing hostages. They came in on Chinooks. One team took a high ridge and shot down. Another team defended it from the lower valley of it behind cover. Another team was in rescuing the hostages, which it's like a big colony. They had to get out 40 hostages, and they kept bringing in aircraft guns. And there's a couple guys that had anti-tank weapons. They held them off, and it's pretty interesting to watch. And then they rejoined and got in Chinooks, and then so they won that one. I saw another one where their mission was I've seen them fail missions too. One of them they got third through it, took a bunch of objectives, got somewhere, and somewhere else they got surprised and pinned down, and the last guy died. And then I saw them recreate the Israeli mission, and when the Israelis went in and took out the, I believe it was Iraq reactor, or was it Iranian? And this I think is Iraq's. I think it was. I'm not sure. This is so long ago. Israelis did it. It's the one where they took their F-16s in and pretended to air traffic control that they were airliners, and they flew in close formation, so they looked in another part. But they went in low level and got so far, and then they got spotted by some, I think they're Su-27s. I don't remember what it was, but and they got shot down. But yeah, the way they were doing, they had a bunch of F-16s going in, that F-15 flying cap over it, and hope was that if something happened, when the real thing happened, they weren't known. I mean, if the mission goes as planned, you drop the bombs on the reactor and leave, and then you come home, and if you have to fight coming home or whatever. But I'm sure they had that, and this happened to this team doing it. They got spotted for whatever reason or whatever. And I think this guy said he'd done it before and it went smoothly. But they got spotted, so the F-15s fought them, and they lost one of them, then lost another one. And so then you're open. The F-16s can get in. Oh, and I think there were some F-5s that were supposed to go and take out an airfield or something too. But the enemies were knocking them out. And they did get a bomb off right next to the reactor, and it probably shut the reactor down because it's in the control room. But none of them made it back, you know. But they also just had enough fuel to get there and back. Probably if they had to fight think they just had enough fuel to drop their center tanks, get to the thing. Yeah, distance was a factor. So I guess in real life, if they had to fight, they would have had to eject. They would have flown back as far as they could and eject, because the planes were gonna. It was a one-way mission then. So yeah, so that's it. So anyway, what I'm saying is in DCS you can do. I'm just using it as a flight simulator, just dicking around with it. But you can set up campaigns with multiplayer. You can have them be airplanes. I've seen people do foot campaigns. I don't know about one thing. They started out in these SEAL boats and drove off and landed here. So I mean, there's just tons of things. Like, I don't know how it's modeled, but like just planes that you can fly, and I can't go buy a Chinook and fly it, but they did get transport. So I don't know how much in this mission simulator you ride in some of these other planes or things or stuff like that. But it's a massive sim. And I was thinking about for training, it's like, if you're into, maybe do a little of it in the sim, but you can train BFM, and you can just have gun cameras. But how do you train missile dynamics? You can't shoot a live missile at someone and expect them to dodge it. You can do the tactics. If I saw you and I did that, it's called the crank maneuver, and I angle off when I see the missile. But you can do in a simulator. You can actually do it and practice it and get used to it. And in tactics, you can't really fire that missile. You can just say I shot a missile off. So I wonder how do they practice that? I don't know. I don't know how they practice that. I don't. Maybe they do it in Sims, or maybe they just don't practice. Maybe it's just like the gun camera. I fired this missile, it has a 50%. What do they do at Red? I have to ask from these pilots, how do they simulate? Because they have like, they have, out in Nevada, what's that big fight they have? Red, is it Red Flag? I believe it is. And they have this team and that team. So they have to be firing missiles. So do they press it? And it's just, he did this maneuver, so he has a 80% chance of living. But you don't have a missile in the air to know if he avoided it. And you don't know about that. So he did that thing. So, the thing is, one tactic is he angles off, do the crank maneuver he does here, but now he's committed over here. Well, now you fire your second missile at him. And now he starts running out of options as more missiles are going. You can outmaneuver one missile, but you get a bunch of them. And then we're getting beyond what I'm talking about, but I would think, the way you outmaneuver is a missile's only got energy for so long. So you make it go over here and here, and then it's now gliding. It's like an airplane without an engine in it. It's not gliding to you. To the last, and the missile goes off here. You get close to the ground, and this radar gets confused with the ground returns of it. So how do they train for that? Where you could do in a simulator, although you don't get all the obviously you don't have the G forces, you don't have the side forces, you don't have the fear of death. If you crash, you look stupid in front of your buddies. You don't have that. So anyway, okay, I'm going on. I'm going to go. But anybody who tuned in, I appreciate it. And yeah, I don't know if I should cut all this out. I just talked too long. I could have been flying right now. Okay. I'm going to cut off. I may come back and do Huey's, but I need a break before I do that.